We intend to record this to make a video today. We do not intend to record your coughing fits or, kicking your chair over, or spilling your coffee, so that can be edited out. We just mostly want the presentation. And you've already agreed to that when you register for the Internet 2 conference, so we don't have to ask you. But we do, your concerns are of concern to us. So this is an attempt to do kind of a different kind of IPv6 presentation where we look at how do you solve problems with IPv6. And I'm going to start talking into my slides, but anyway, I'll introduce the band. Jeff Harrington from NYSERNet is a curator and keeper of the NYSERNet Internet IPv6 tutorials. And I can say that if you want to negotiate with him to have him come to your school, you should talk to him. Jeffrey Handel is from Cisco Meraki, formerly of Louisiana State University, and he's part of my presentation. Richard Machida is ironically one of the former deliverers of the Internet 2 IPv6 workshops, and is here doing the audio and video producing. Yeah, and I'm Alan Winery, co-chair of the Internet 2 IPv6 working group with Michael Lambert, which it's a great thrill to be able to stand up anywhere and say I'm co-anything with Michael Lambert. And we do have a meeting tomorrow-ish at lunch, which you're welcome to join. And also I have a mold allergy and I live in Hawaii. I don't smoke. So one cough drop in the context slide. So at UH, we've been running production dual stack for IPv6, IPv4 for 9 years. We've been doing v6 in some form for 14 years. A considerable proportion of the content accessed by our dual stack users is accessed by IPv6, about 30% by flows, 60% by packets, 50% by bytes. When I talk about the possibility of obtaining around half of our content via IPv6, I'm talking about something that our customers are doing right now. In 2008, we declared that there was no IPv6 guy. You're all IPv6 guys. And Matt, who's from our shop, can attest, we just do IPv6. People learn IPv6 on the job, and nobody really finds it to be onerous. We haven't sent anybody to Jeff's training. Maybe we should have Jeff come to Hawaii. And if you are an I2 member institution with TRCPS and I2 connectivity, and possibly IPv6 commodity besides, this will apply to you equally. There's an awful lot of content, meaning there's an awful lot of content that you can get over IPv6 at this point in time. So this is one zone of our UH Manoa wireless. On a business day, campus-wide, there can be as many as 15,000, 16,000 devices. And we're doing native IPv4 and v6 addressing for all of them right now. On one zone, which has about 8,000 users, the most busiest zone, you'll notice that the flows per second, the top graph, V4 is red, V6 is green, and V6 is considerably lower than V4, but it's about 30%. If you look at packets, however, V6 is actually looks almost a little bigger than V4. And you look at bits, and it's like about half-half. Now, one could postulate, I haven't really looked into this deeply, but two of the heavy hitters that are available all V6 all the time are YouTube and Netflix. And those would be high numbers of packets per flow content and things like that. So that's probably why the disparity between flows and et cetera, et cetera. Of course, we can, hopefully in a future version or a future talk, we'll have more detail about that. Now, this is a Noel Chiappa quote. And of course, you all know who Noel is. Maybe not, if you're old enough. Noel Chiappa actually drove the development of the MIT Gateway, the first ever IP router at MIT in the early 80s. Early mid-80s, and went on to be one of the drivers at Proteon. But better is the enemy of good. And I realize the hazard of putting this up on an IPv6 talk, because you might say that IPv4 is good and IPv6 is better. But if IPv4 is good, you're going to have to explain that to me, because it's reaching the end of its useful life. So IPv6 has been around for a long time. Until it's useful to build networks by itself, it's not solving the problems it was created to solve. Dual stack has shown us many things about operating IPv6 networks. Every day, IPv4 addresses become more scarce, and if you can build IPv6 networks, growing in IPv4 is increasingly a folly. Means exist to start building single-stack IPv6 networks and providing IPv4 as a service, but everyone has their eye on the next better scheme. So what I mean by that is better is the enemy of good. The IETF is doing what the IETF is supposed to do. They're supposed to discuss things to death and come up with, various solutions, and various solutions are influenced by the input from various groups. But what happens much of the time is people are watching the IETF, waiting for something that's going to come out in the next 2 years, 4RD being one of the examples, and not focusing on what they can solve right now. So our talk today is about what you can do right now. So question, why do we deploy IPv4 NAT, L2TP tunnels, GRE tunnels, BRAS, MPLS VPNs, NATs inside NATs, port forwarding and UPnP, SIP-stun, firewalls, JB Weld, and duct tape? Because they solve problems. IPv6 is not meeting that criterion yet, because, well, people are in denial about it meeting that criterion, and we're, examining our navels instead of moving forward. So we need to put better tools in the toolbox. There need to be solutions for v6-only networks, tools that actually address address exhaustion and reveal the intrinsic incentives for IPv6 deployment. And how long have we been promoting IPv6 deployment based on its offering solutions at some vaguely defined time in the future? Well, however long, ending in now, because we're still doing it. The landscape changes while the song remains the same. I keep ending up with Black Dog in my head after this slide. But if you didn't get it, ask the guy next to you. Big content has really stepped up. They really have. Like the biggest content has really stepped up, and content distribution has stepped up. Akamai and Cloudflare, and there's, I think, Limelight's into v6. There's a lot. They really get it, and it's solving problems for it. It is the duct tape of the early 21st century.
And if I may add to that, back in the early days of v6 deployment, that was one of the biggest questions. Places that you know of, but 2011 came around with the IPv6 day, and then IPv6 World Launch Day in 2012. That changed the ballgame completely, because hey, we can get to stuff and be useful and productive, and hey, this presentation was just downloaded on a v6 network, not v4. Before you'd have to switch back and forth to figure out how to download it to yourself.
So Google, YouTube, Wikipedia, Netflix, and XKCD on IPv6. That's almost everything I ever browse. And then Facebook, I hardly ever go there, but I have ended up there lately a couple times. And then Akamai, it's in the woodwork, and Cloudflare, and et cetera. Numerous large residential providers are providing dual stack to homes. The local and regionals are a little bit behind, it seems. I've got Time Warner Spectrum at home, and they delivered a Technicolor brand router with dual stack in it. And it actually has a couple of mistakes in the implementation for DHCPv6, but it's dual stack right down to the screws in the feet, and it's well done. So that's out there. Cellular carriers are another place. Cellular isn't really the right word. Mobile carriers. T-Mobile, I did send out one T-Mobile talk by actually the same talk that's in this PDF that's in the slide. And they're talking about they actually kind of moved to a network very much like the one we're going to talk about today. Verizon has been dual stack very reliably for several years. AT&T I don't really understand. I don't know, maybe somebody in the room does, but there's this kind of interesting handcrafted proxy network thing going on with addresses that look like that or like that.
Yep, and on the same token, I mean, like Alan was mentioning earlier, I mean, we want to solve problems with V6. Well, the carriers had big problems. They didn't have enough IP space, and that was not the solution. They would
Jeff?
break stuff.
Mike.
Oh, and so, I mean, that's one clear example of how V6 helped them solve solutions. I mean, this happened many years ago without any one of us knowing. It just because of need to solve a problem.
And there's a great Comcast talk from like 10 years ago where they're just their CPE, their set-top boxes management. They filled out the 10.0.0 network with 16 million devices, and they had to split it or move to V6. So they decided to move it to V6. So that was like the first IPv6 solution talk I ever saw. Also, the song remaining the same, most journalism about IPv6 transition is parroting something they were told 5 or 10 or 15 years ago. Or worse, they're asking your boss instead of asking you, and he's parroting something he or she heard of, 10 or 15 years ago. But the landscape is changing. The state of IPv6 deployment and the availability and the usefulness of IPv6 is changing all the time. And plus, hooray, there's now a growing industry in the IPv4 brokerage with a commitment to prolonging the use of IPv4, because if IPv6 starts to eat into the value of IPv4 addresses, they lose value, which I'm not making any accusations, but it's just the facts of the economics. I just got one of those emails like 2 days ago. So, and if you go out in the world, if you can find somebody that knows what IPv6 is, which many people do, they all understand that IPv6 deployment is a long ways away. And I don't know if you've noticed, but everyone really isn't anyone. Journalists, bloggers, self-proclaimed authorities are parroting what they were told in 2006. The purists are arguing in the ITF mailing lists about sticking to their guns on divisive issues, and as if there's not anyone who needs to deploy now. And there are many people who could benefit from what V6 has to offer them. And then there's the deniers who just insist that we should just all do more and more NAT and keep IPv4. And my message to them is to go back to moon landings. IPv6 bingo. Yeah, you've all probably already gone there anyway.
It looks like he already went to it if he's laughing.
So feel free, but I was going to spend a slide, but we're going to get this intro over with so Jeff can talk. Setting all of that aside, what if I really, really need to deploy today? I have a group of friends at a campus on an island in the Pacific that have a /28 of v4 for their entire institution and several thousand constituents. And they can either NAT the bloody bejesus out of that, or they can do v6, right? Or et cetera, or find more addresses, buy addresses, there are other things. But I think that making the v6 option available to them, and they've just done a deal where they're getting a different kind of connectivity into their campus, and the contract includes v6 from the ISP. So there's an opportunity there, one, to hold the ISP to their word, and two, to start to make IPv6 a solution for them. So. Also, my contention from my last talk at Global Summit was, if you're not actively seeking to deploy IPv6 right now, you are the reason that deployment is a long way away. Because, you're going to ask something? Are you going to say something? What?
Deployment is not a long way away. We are within 12 months of 50% deployment in the US.
I know, but go out and read. So I'm not talking about Scott Hogg or Eric Vinke or Cricket Lou or all those people that are pretty much on, Jeff Houston. There's a lot of really smart people, but the majority of everything out there about IPv6 is saying it's in the future, maybe in the 23rd century. So they really got to get their story straight. But yeah, so.
In fact, if you haven't deployed V6 yet, you are officially no longer an early adopter.
Yeah, right. Yeah. Yeah, you missed the early adopter wagon. But well, yes. So I'll share you with something I noticed, and hopefully stop crossing my arms over the microphone. So this is Google's map, which is great and probably accurate for what it shows. And it's got a lot of white countries on it, which means that there's very low what they call adoption in those places. In Botswana, there's a little bit of a performance issue. There's some V6 that shows up there. Actually, they're at 0.01% adoption. Botswana rounds to 0. Cuba's the one that's at 0.01% adoption, which is interesting. And but everybody's seen this. And there's a very similar thing at Akamai, which shows. So what I want to talk about is I took 3 months of flow records, and I sifted through them, and I made a list of every V6 address that we heard our machines talking to during that time. I didn't take the ones that were talking to us, because that could be spoofing and scanning and whatever else. And I got the very predictable pie that you see here. It's the hump and the frequency histogram, the U.S. and Ireland, Great Britain, and a clutch of unidentified from MaxMind GeoIP. Germany, Netherlands, Canada, Australia, Japan, and Romania, which I'm not sure why. So over a 3-month sample, Romania was in the top 10. Someday I'll have to go look at why that is. Yeah, it could be. Well, no, but it's just, you see, I'm at layer 3. I don't care why they're doing it. I just want to see the working.
You asked about Romania.
Yeah, okay.
People responding to fishes.
Okay, and we don't intend to disparage Romania. But I noticed this other thing. In the long tail, here's, is it Barbados?
Yes.
Okay, Barbados, because I know you were there at Erin. So in Barbados, which has a 0% adoption according to Google and Akamai, one of our hosts interacted with what looks like a Facebook cache, because it has FACEBOOC in the address encoded in there. And nope, traceroute brings it to traceroute, and you check the hops along the way, and it's Barbados. And the thing appears to be in Barbados. Oh, I know what you mean. Should I go on? So, but anyway, yeah, so Akamai and Google say 0%. Eric Bink's site is actually better and more detailed. But it raises a question. If they have 0% adoption, that makes it sound like there's nothing there. You should just not count on Barbados to be IPv6 connected at all. And, they're not. But the truth is, they are, and you can ping them. You can ping that Facebook cache anyway. On the government telecom section site, there's a thing about preparing for IPv6. And like all of us, they may have had that there for 5 years. I don't know. I have things that are on 5 years. But if you start looking at that long tail, there's all these other places that have infinitesimal adoption, but there's a pingable address in those places. So there's a router with V6 in the OS with an interface, at least an interface facing out. 2 of them were Facebook caches, or what I'm calling Facebook caches, and the rest of them were handcrafted addresses. They were like a /32::1, right? So it was somebody trying to get a pingable address up there. I don't know if they were meeting some milestone that they needed to meet, but a lot of them are very similar. And these are just ones that I picked from the very, very end of the tail. And there are probably quite a few more in there. Equatorial Guinea is kind of interesting because Malabo, the capital, is actually on an island off the coast of Africa. And it's not even off the coast of Equatorial Guinea. It's off the coast of Cameroon, which is a ways up. So it's the perfect illustration that having a pingable address in the capital does not mean you're connected to the rest of the population. But it's more than nothing. So there's more connectivity out there than the 0% adoption would suggest. So if we start having conversations and start providing information about how to use IPv6 to build networks and solve problems, it incentivizes future deployment. And I think it's possible to make a lot of map greener in a short time when that breaks.
Just to help you note, the adoption is client adoption, not server adoption.
Okay. Well, that's the thing about visualizations and metrics. You have to, well, Mark Pryor's page, which shows services throughout U.S. universities, shows nothing about the client connectivity. Because our network has all the clients are available on the large campus, or most of the clients are able to do v6 out, but practically none of our services are there. Yeah.
65, 70% client adoption,
Yep.
almost zero on the servers.
Yep.
And so you'll find that there's going to be countries that are kind of the other way around, almost zero on the client and
Right.
some level on the server.
Well, I gotta wonder, because there's a Facebook cache there, if there aren't some clients, you know, so,
No.
or maybe they're just serving clients.
If there's a Facebook cache there, Facebook deploys their cache.
I see. And the clients all hit it from v4. Maybe.
Yeah.
Okay, so we should get some Barbados people in the next discussion, and we'll talk about that, or any of those guys. And to show you, I already checked for this, so you're sitting there thinking, oh, those are all Teredo and 6-4. No, I checked for all of that. And these two guys, interestingly enough, were 6-4. One hit out of 146 million hits came into us. It was on v6, but it was 6-4 on both sides. I didn't see Teredo from other countries. Well, I'm sure I did somewhere, but. And here's a list of all the measurements that I could fit on a slide, except for Eric Vink's, which is up in the other place. Yeah, it's right there. We'll make these slides available, even though we haven't yet. But that's the intro. So Jeff's going to come up and talk about IPv6 security. And the reason for that is, yeah, and because it's the most valid concern that people express about moving to v6, and it needs to get addressed. People need to get some comfort about security before they move forward. And he has a talk on it. So we're going to do that, and when he is done with that, we'll probably go to a break, and then we'll do the NAT64, DNS64 stuff.
Yeah, well, they're setting up. A quick question for the room. How many of you guys have deployed v6 that you know of on your campus?
Oh.
Oh, sorry, man.
Mm-mm.
Just a quick show of hands. So
Okay.
hopefully everybody.
Yeah.
Which campus are you with?
Entertain them for a minute while I get there.
Merced, okay.
Do you have it on par operationally with v4 for security?
You're not
We sort
allowed
of
You're not allowed, Bill.
Okay. We at NISNet did our annual conference about 2 weeks ago, and I moderated a panel for our 4 campuses that have deployed v6 throughout their campus. And it turns out, when we were going through the slide deck, and we wanted it to be a practical presentation of here's the problems we ran into with v6 security, and here's how we solved them. We all kind of determined that we're not doing a very good job of this. And a lot of that had historical reasons of they'd started to deploy IPv6 a number of years ago, and there was equipment that couldn't support some of the features, so they deployed it anyway, thankfully, but they never went back in and fixed the problems that they had with switches not properly doing first-hop security, firewalls or VPNs that didn't do the job properly or did it in software, and they never went back in and turned on these features. So I'm glad that Alan asked me to do this because I wanted to go through a slightly modified version of what I do during my overview of IPv6 and just hit on some of the highlights. And I know there are a lot of people in here that are, have done v6 for a number of years. This is an overview. I do gloss over some things for time, but we can discuss. I have about an hour. I have about 80 slides. I will go quick. Yell if you need to say something. The first thing I always tell people is evaluate your IPv4 security practices. If you're doing something for security in v4, there is hopefully a reason why. In most cases, there is the ability to duplicate that or replicate that in v6. So if you have, whatever your policy is with your firewalls or with your business practices, do that. There is one thing that causes some consternation in terms of doing best practices is how many of you have services that are based on this IP address are allowed to access this resource? You will not be able to replicate that in v6 successfully. And that's due to Slack. And by the way, I am not a purist for either Slack or DHCP v6. I don't care what you guys do. But with Slack, assuming privacy addresses and not stable privacy addresses, we're not going to get into addressing, there is the possibility that a user's IP address will change on a daily basis. Or less, about. So if you are doing your access list, your host-based access list for your resources based on this person with this IP address is able to access this resource, but that address changes, give or take daily, good luck keeping that access list up to date. And you could say, well, okay, I can say that this subnet is now allowed in. Do you have anyone external from your campus or your environment accessing that resource? Another PI from another university that's a co-researcher. You have absolutely no control over what they're doing, what they're addressing. So if you are doing host-based access control, you're going to need to find another solution. I'm not going to offer solutions because I'm not going to do that policy for you. But know that that will be something that is an issue. And in the NISNet world, there's a lot of people that are doing this type of thing, so they've had to come up with a myriad of different solutions. And we like to say with our campuses, if we have 10 campuses, they'll come up with 13 solutions. So your mileage may vary. Know that this exists. If you have vendors come in, and you are all interested in v6, and you sit the vendor down and say, what about your v6 security? And if they actually utter the words to you, well, v6 is more secure than v4, pick them up out of their chair, move them to the door, shut the door behind them, and lock it because they don't know what they're talking about.
That's if they know about
that,
IPv6.
well, yes, unless they say, as John Curran has said, you ask them about v6, and they say, you're the first person who's ever asked me this. And yes, you've probably all heard him tell that story.
Get those answers, do more than just lock them out.
Yes. Just like IPv4, IPv6 is as secure as you make it. If you have a secure IPv4 network, you can make a secure IPv6 network. If you have an insecure v4 network, I wish you luck, and you can very easily make an insecure v6 network. It's IP. You can do what you will with it. There are still some of the same threats in v4 as there are in v6. You can sniff. There are actually more types of rogue devices in v6 than there are in v4. There are definitely man-in-the-middle based attacks. You can do flooding. All of those types of attacks are available in v6, including the higher level ones like phishing, which are the ones that everyone really sees these days anyway. That has nothing to do with the IP layer. One of the things that people say that make IPv6 more secure than IPv4 is IPsec is built in. So it is in v4. Yes, you have IPsec available to you now in v4. Other than site-to-site VPNs or remote users, how many of you have IPsec tunnels in your network for regular traffic? All everywhere?
No.
Yeah. Yes. You're the first.
I would argue that probably a lot of you have them and don't even know.
But it's not something that you're actually the first person that's ever raised their hand when I've asked that question. Because again, you have remote sites that you've built tunnels for, your VPNs, things of that nature. Sometimes. The point is you have IPsec available to you in v4, and you're probably not utilizing it for everything that you could. The same is true for IPv6. You can certainly turn up IPsec tunnels in IPv6. It's built into the stack from very early on. But unless you plan on configuring IPsec tunnels from everywhere to everywhere and all of the overhead that exists in that, it's a tool that's available to you. Nothing has changed from v4 to v6. When I usually give my class, most of the people have not implemented v6. So when I get to the slide, I say, most host implementations, and I could probably say all host implementations, have IPv6 on by default. So when everyone comes in, yes, there are still some people that have some very old machines out there. So when I say that to the class of people that are all running all IPv4 only networks, congratulations, you're running an IPv6 network, you can go home now. You don't need to learn anything else. All machines will communicate with each other. Again, all modern machines will communicate on a shared network using link local addresses, the FE80. So everyone is running an IPv6 network, whether or not you have it widespread. Every machine-to-machine communication on a subnet is using link local. It's auto-configured, no involvement, unless you turn it off in group policy or something like that. Because of that, if you are not watching for IPv6 threats or people potentially utilizing the network for nefarious purposes, they can get on that link local network and start scanning or start gathering information or doing what they will if you're not watching for it. Now, many of you have many, many years of IPv4 security practices and monitoring and reporting that you're doing. For everyone that's running IPv6 networks, do you do the same type of monitoring and reporting for your v6 networks as you do with v4? Yep. I knew you would say yes. In most cases, that is not true. Exactly. So, right, it's a, you know, are you gathering host addresses? Are you watching for scanning? Are you watching for rogue devices? Are you doing this? For all of the things that you're doing that monitoring and reporting on v4 for, in order to have a production quality v6 network, you have to be doing it for v6 as well. I always say there's a big difference between implementing a network and operating a network. It's easier to implement a network, just put it in place and walk away. Yes, it's turn it, you know, most of the time it's turn it on, let it go. To actually operate a network is much more difficult, and you have to put a lot more systems in place, and that's a lot of what I want to talk about.
Yeah, and
Jeff.
if I may add too, I mean, this is a situation where clearly the clients have been ahead of us for quite a while
Years,
now.
a decade.
Years. So the fact that you're running a v4 only network, you're just left yourself vulnerable, because the first rule in security should be run a v6 network to start locking it down and controlling it, because somebody else will do it for you. And that's it's a double-edged sword, because it's also the beauty of it is you start running your v6 network, all of a sudden you get a ton of traffic because the clients are ready to go.
Yes.
You don't have to wait. So that's where a country like Barbados can go from one hit to 1 million just by turning it on everywhere else on the routing.
In terms of topics I want to talk about, there they are on the screen. First top, layer 2, layer 3, edge, appliances, and applications. First top security, I'm referring to getting workstations or end stations attached to the network. IPv6 is a layer 3 technology, meaning things like 802.1x, if you've implemented it, that's layer 2, still applies. Running an IPv6 network changes nothing about that. First top security in v4, I like to do a lot of compare and contrast, securing against ARP-based attacks, rogue DHCP servers, and packet sniffing. Because IPv6 does not use ARP, because it does not use broadcast, the ARP-based attacks or the mitigations for ARP-based attacks do not exist in v6 because there's no reason for them to exist in v6. But there is neighbor discovery protocol-based attacks, and that is roughly analogous. You still have to protect against rogue DHCP servers and packet sniffing. You also have to protect against rogue routers. And again, I'm assuming there's a relative knowledge base. If you have questions about some of this, please find me afterwards. So neighbor discovery protocol. Again, that's part of how machines get on, that is the way that machines get on the network in IPv6. So you have your neighbor solicitations and advertisements, your router solicitations and advertisements. All of these are ways that people can keep you from getting on the network. So securing NDP means that solicitations are only sent from valid hosts, and only valid hosts return advertisements. So earlier in the slide deck that I normally have, we have a situation where a machine is trying to get on the network. And when it does that, it sends a neighbor solicitation from its own address doing some duplicate address detection, saying, does anyone else use this address? And one of the more common ways to keep someone from accessing the network is when they send out that router or neighbor solicitation saying, does anyone else using this? Another machine will reply, yep, I'm using that. Okay, let me regenerate my token. Is anyone using this address? Yep, I'm using that too. So if the machine is unable to make sure that it doesn't have, or make sure that it can get on the network with a neighbor solicitation and a no neighbor advertisement, can never find its router, can never get its prefix, can never find out if it's doing DHCP or Slack, and just it's off the air. Interestingly enough, the specification for securing NDP calls for IPsec because, hey, IPsec is built in. But IPsec requires IKE, which requires the IP stack to be functional, and you're doing this in order to make sure that you have a valid IP address. So there's a significant bootstrapping problem with using IPsec in order to secure your neighbor discovery protocol. So don't do that. Again, 2 vectors, denial of service and redirect. Yes. I'll get there with send. That's even not keys, but yes, distribution problem. So the DOS-based attacks are what I was just talking about, a way for a malicious user to keep a machine from getting on the air by spoofing that neighbor advertisement response to the initial neighbor solicitation. There are also redirect type of attacks where you send out a neighbor solicitation saying, hey, I want to send a packet to this host. Some bogus machine sends out that neighbor advertisement saying, yeah, send it to me. Same thing with router advertisements. So again, what I was talking about, send out the neighbor solicitation requests. You actually get a neighbor advertisement. If that occurs, now again, if you're using a Slack-based addressing scheme with 64 bits of potential host addresses, if someone has actually managed to go through the mechanism of generating a pseudo-random 64 bits and it happens to be the same as yours, go buy a lottery ticket because that is incredibly unlikely to happen.
It's related to the birthday problem.
Yes. Which is, slight tangent, which is why I was on the side of don't make the 64 bits any smaller during that discussion a month or so back. Redirect attacks, again, we all know what redirect attacks are. You're trying to find out the machine address or another address of a machine. Someone spoofs the advertisement. Again, this is analogous to an ARP-based redirect attack in v4. We're aware of those, just, it's not ARP, it's neighbor discovery. Same idea, same mitigation strategy. Again, I try to reinforce this quite a bit. Malicious hosts attempting to hijack legitimate traffic. In v4, spoofing can be mitigated by a number of different ways, depending on what you've done. You can do port security. You can do dynamic ARP inspection and DHCP snooping. You can do ARP-based ACLs. Again, none of these have direct analogs in v6 because there is no ARP. However, there are ways to do this, and there are ways to do a similar thing in v6. There are DHCP v6 snooping is available in most vendors' switches. Again, if you have older hardware in your closets, it may or may not be available, or it may only be available in software. Your mileage may vary depending on when your last network refresh was. So that's why I say they're not necessarily available. But when was the last, I mean, I have people that we were talking just a couple weeks ago in that presentation where their closet switches are 10 to 15 years old. There is zero chance that you will be able to do snooping successfully on those switches, even if it's available to you. Right. So know that it is available in modern switches, in hardware, but don't plan on this as necessarily a strategy that can be widespread. But there are some other methods. There's IPv6 binding tables. There is neighbor discovery snooping and inspection. Again, your mileage may vary depending on your hardware. You can do IPv6 port ACLs. And on network hardware, I will come back to this, so please don't go there yet, there is secure neighbor discovery. This is usually the method that I've talked to most of my campuses about, is the binding tables. Allows for a maximum number of neighbor discovery table entries on a switch port, similar to ARP-based port security. It can be done dynamically with neighbor discovery inspection and snooping, again, depending on your hardware, so that the inspection will listen on the port for the neighbor discovery responses. They again, are periodic, both solicitations and advertisements. It will listen and generate a table based on, I'm going to, you as the administrator, I'm going to set this port to say, I'm going to allow one neighbor discovery entry on this port because I know there's only one machine on this port. First one it learns goes in the table, that's the neighbor discovery entry that's allowed. If someone on that port were then to say, well, I'm going to send out a new entry for the neighbor discovery table, it will then flag it as being out of spec and do what you will with it, either shut it down, warn you, send an email, do whatever you want. So again, you can set it up for a certain number of entries per port, which will allow you to do away with the malicious user always responding back to those neighbor solicitations, things of that nature. You can do, okay, I think there's going to be one entry, but just in case I'm going to put a handful on there in case they start doing Slack and start moving addresses. Or you can say, I know this person is going to plan on putting a 12-port switch behind this port, so I need to make sure that I have enough entries for that person to be able to put a layer 2 switch behind there. Again, depending on what the situation is how many entries you want to be able to put on there. So you'll never want to actually put one. You'll want to have it, but you want it to be a small number. Again, depending on your environment, whether you're doing DHCP, whether you're doing Slack, what have you, you could standardize on a half a dozen. You could standardize on 10 if you want to make it safe. But you will still run into problems of if someone decides to put a 12-port switch on there. So if you decide, I'm going to standardize on 10, that will solve most of your issues regardless of whether you're doing DHCP v6 or Slack, and have that be your standard. And then if someone comes in and plugs in a switch, well then they're an anomaly. Deal with those as you will. But plan on doing something standardized. You don't want to do it on a port by port. Well, this is 5 and this is 10, and don't do that, please. So again, you can do it globally on all your switch ports. You can do it on a per switch basis. But this is definitely something that will help limit anything malicious going on in terms of the number of hosts on a port. That again, again, just to make sure it's on the audio, that RFC was not a best practice not to limit the number of addresses that a host can have on a v6, again, glossing over some of the details. That goes back to the age-old network operator versus security operator argument that will define the existence of our lives and our great-grandchildren's lives. I, being a network operator and not a security person, if I'm operating a campus network, I'm going to make it as secure as I possibly can, even though I'm always of the, I want packet in, packet out as fast as possible, free love and bandwidth, all of that.
And what I'll say, this isn't necessarily network operator versus security, it's actually network and security versus applications.
Yes. So, again, high-level overview. We can talk about that offline. I want to make sure we get to everything. Again, there is IPv6 7934. Is that RFC? Okay.
That was close.
Doing it off the top of your head, that's good. So again, you can do port ACLs, again, somewhat similar to IPv4 port ACLs. There is a IPv6 destination guard that's in Cisco and some of the other users, again, doing similar macro-based learning the neighbor discovery entries and locking down the ports. Again, similar to what you would have expected for ARP in v4. With the caveat that IPv6 hosts will always have more addresses than IPv4, both link local and multiple global. So send. I mentioned before, someone coming in and saying IPv6 is more secure than IPv4 because of IPsec. Send is the other one that you will occasionally hear. This is the silver bullet that will secure our networks and will never have people accessing our network that are unintentional. We'll all get together and sing Kumbaya, and our networks will be happy.
Good luck deploying.
I'll get there. So secure neighbor discovery involves a extension of the neighbor discovery process that requires certificates and key pairs. So there's a new set, instead of just neighbor solicitation and advertisement, router solicitation, advertisement, there is now certificate path solicitation and certificate path answer. Why they changed to answer instead of, I don't know. So there's some cryptography associated with this, and I took out a lot of these slides for this because
If you could spend all day on it.
could spend all day on it, and there's one slide that ends up being the be-all and end-all for this. So how many of you on campuses have more than 15,000 devices attached to your network on any one day? How many of you would like to have certificate pairs for every single one of those devices in order for them to access the network? Exactly. So using send, every single device that attaches to the network must have a key pair. I'm sure all of you control all of those end devices, and they're not BYOD and phones and tablets and Xboxes and all of that type of stuff. How many of you want to be in charge of all of those certificates? I'm not seeing very many of this. And then again, of course, renewing them all of the time and doing everything associated with certificates, which I'm not being down on certificates just for all of these devices. Yes. Well, and a BYOD problem as well, and not just a chicken and egg, but a BYOD. So before configuring send, again, hosts have to be configured with trust anchors. There has to be an RSA key pair. There has to be routers with configured with the RSA keys and the certificate chains. All of the stuff associated with certificates. But here is the be-all and end-all slide for send. It's supported in Cisco. It's supported in Junos. It's supported in some packages of Linux, but it's not supported in Windows and Mac OS or Android. This sounds like a technology that we can fully deploy inside all of our networks. Never. So with someone, for Windows, yes. I haven't looked for Mac or Android. I would not be shocked if Android there was not. Regardless, if you have out of those 15,000 devices that are attached to your network, 12,000 are BYOD, and third-party clients are not, and not so much for iOS, but for Android. How many flavors of Android are in your network? Do you really want to be testing third-party applications for that? So there is a significant problem with send. In the panel discussion we did a couple weeks ago for First Top Security, I basically put a bullet that said, ignore the fact that send exists, because it is an unsupportable technology, yet I still see articles or blogs or whatever hyping it. And again, as Alan was saying, it's like, you just simply do not understand what you're talking about. And I'm not the expert on security. I mean, I've talked about this a lot. I've worked with a lot of people. I'm not a security engineer. But I can tell you, ignore the fact that send exists, and you'll be a happier person for it. And if a vendor comes in and starts talking about this again, politely show them the door and lock them out and never return their phone calls.
Unless they're supplying the entire solution.
I wouldn't even talk to them then.
Yeah, well, this is one of those situations where the client is not ahead of the network guys.
Yes, and again, even if the client supported it, even if it was fully supported by everyone across all of the different versions of operating systems, we're talking multiple tens of thousands of certificate pairs.
Wild cards.
Still, on BYOD devices, I would not want to have anything to do with that. Right, exactly, and that's.
I'm just saying there are use cases where it could be deployed.
Yeah, if you're trying to do a small implementation for like student records or for a health system or some small subnet where the clients actually supported it, and you wanted extra security on that subnet, in the future when clients supported it, I could see an implementation of that. But to put on your campus wireless network, never. So again, moving on, I'm just trying to make sure on time. Rogue DHCP servers. Again, just like with before, you've all dealt with rogue DHCP servers. They still exist in IPv6. IPv4 IDS systems do a pretty good job of finding them, reporting them. You can send out the team with the pitchforks and torches and get rid of them, or shut down the ports, or just shut down the port. Yes. So DHCPv6 security in IPv6. Again, snooping is integrated in many of the modern switches. There's some documentation there for Cisco, Juniper, and HP. I try to be a little bit vendor agnostic here. Again, depending on what hardware you have deployed, that might not be an option for all of your switches. You can also configure it manually. So you can do a manual access list on your ports that block any host-based ports from applying to DHCP v6 queries. Same thing with Juniper there. And again, these slides will be available later on. So in addition, and I apologize, I threw a new theme on here and didn't check all of my slides for the spacing. Similar to rogue DHCP, you will have to protect against rogue routers and IPv6. This is not something that you have to do in v4.
Well, technically, the protocol doesn't exist before.
Right. No one has had to protect against it in v4. So the thing about IPv6 is the way that the neighbor discovery protocol works. When a host first comes online, it sends out a router solicitation, hey, where's my router? The router replies back. But that has a timer associated with it. So the host or the router has to send out a periodic refresh of that timer, so it sends out an unsolicited router advertisement. And the hosts are expected to listen to unsolicited router advertisements to update those timers. Because of that, hosts are listening to unsolicited router advertisements. And if a rogue router comes online and sends out a router advertisement, the host says, hey, there's a new router. I listen to unsolicited router advertisements. Great, I have a new router. This is something, again, built into IPv6 that you just have to deal with. So again, you can do things like on user-facing ports, do not allow router advertisements to be sent through them. Another thing, Windows with internet connection sharing. This was a big one a while back. So anything with ICS, you're on an IPv6 network, you turn on internet connection sharing, congratulations, that laptop is now a router. So you'll want to be careful of that. If the rogue arrays are blocked, malicious hosts could be able to announce to your network, whatever subnet they're on, I am the router for this network. And depending on what happens, there are a few things that could happen. So it could forge responses from the legitimate router. It could redirect traffic saying, I am now your router. Traffic will go to it. If it's not encrypted, all sorts of things could happen to it. Maybe, maybe not. Can do some man-in-the-middle type attacks. It could, depending on what's going on, if it's just someone being stupid or someone being malicious, it could readdress your network on you. Because all the other clients on that subnet will happily take subnets from multiple different places. It could be multiple routers, could be Slack and DHCP, it could be any combination therein. And again, I don't remember the RFC, but there's an RFC saying if you have multiple global addresses, it's up to the user's machine to say which address is the one that it wants to use for outbound traffic. And like most of you, I don't trust my users to have that kind of intelligence. So Dave, you have a comment?
I'm going to say this is, if you go back 20 slides. Don't go back. If you did go back 20 slides, you said, hey, if you're doing v4 only,
Yes.
this is the problem you have if you're doing v4 only.
This is one of the big problems. If you have a v4 only network and you are not monitoring for v6 traffic, and someone comes on your network and says, let's do something, let me share my connection with you, and turns on ICS. That sole subnet now is v6 capable, and all of the traffic is running through that laptop. Because they're all talking on link local, and that machine is now a router.
Assuming a non-malicious.
That's assuming a non-malicious, yes.
Okay.
I'm assuming that most of the situations that we're talking about are not malicious, it's just people not knowing what's going on under the hood. The whole point of security, v4 or v6, is to stop the stupid stuff. If someone really wants to break your network, they will find a way. Make it as difficult for them as possible. But if someone really wants to do something and take down your network, they will find a way. If you can stop the vast majority of stuff, or people that are just running scripts, great, you're in good shape. But if you have someone that's on your network that really understands what's going on and wants to do something bad, they will probably do it. That is a much smaller percentage of the people plugging in things backwards, which is what we're trying to fix.
And if you're ever bored, there's a toolkit called Hacker's Choice. Just sit in an airport, start spewing out arrays. You can get everybody's traffic going through your machine. But then you may have to just shut it down, so it'll be everybody's traffic. But it's really, really easy to do. That's why run v6.
So there's two methods to block rogue router advertisements. You can do the manual filters. Deny ICMP any router advertisement. Please only place that on ports facing users. Do not place that on ports facing your router. And set your router port, the switch port facing your router, the router port facing the rest of your users. IPv6 ND router preference high. Very simple solution because most of the other stuff, people plugging in a small office, home office device backwards, someone turning on ICS, that's normal router preference or medium or whatever it is, depending on the implementation. That's a really simple way to stop most of the stupid stuff. Right, it won't stop malicious. There's other ways to deal with that. But if you just stop the stupid stuff, that's 97%.
Yeah, I've actually never seen a malicious attack of that in the wild.
Right, they're much more rare than someone doing something stupid. So you set your router preference high. It's not like you can walk away, but you've solved most of your problems. Again, there's the manual filter for the Juniper. There is also RA Guard, which was famous for being broken hours after it was released because they found out if you chain extension headers, you can break it. Again, if you're just trying to stop the stupid stuff and not the malicious stuff, RA Guard works perfectly fine. I would still set the router preference to be high on that router port facing your users. Again, it's a very simple command. It solves most of your problems.
This is one of the places where defense in depth is a good thing because it's not like nothing ever breaks.
Right. Yeah. Oh, that's so. Do RA Guard. Do your user-facing ports blocking router advertisements from them. Do your router preference high. Again, these are not very difficult to do. If you do all of them, again, you're stopping all of the stupid stuff.
And you have some redundancy in that.
Yes, redundancy and defense in depth is always good, especially for stuff that's this easy.
Yeah.
So again, RA Guard has been available for years. ProCurve, HP ProCurves have do it. Again, Junipers will do it. The one thing I recommend to most of my campuses, even if you do not have significant plans to widely deploy IPv6 on your network, deploy this now. Because all of your routers and all your users understand IPv6. This does not involve any addressing of your network. This does not involve any kind of implementation of IPv6, but if you put that access list on your user-facing ports, you stop all the stupid stuff. So I've recommended this to I don't know how many of my campuses that are saying we're still 2 years away from IPv6, and after I'm done hitting my head on the table repeatedly, I said, please at least do this. Because that will, if you're not deploying IPv6, you're not watching for IPv6, which means that all of this can be going on and you will not know about it. And the next thing that's going to happen is someone will come to you and saying, why did this happen? And you will not know why, because it will be an IPv6-based something. So please, please, please put this in. Again, this is the Cisco-based. There's a Juniper-based one right here. We'll have the slides available later so you don't have to worry about copying them now. Please, please, please do that. If you have no IPv6, if you have some IPv6, if you have fully deployed IPv6, doesn't matter, do that. Layer 3, routing protocols, some control planes, and again, some IPsec, because I wasn't really bashing IPsec before, because IPsec is perfectly fine. So we will talk about how to implement it. Routing protocols. How many people secure their routing protocols in v4? Yeah, you can secure them in v6. In pretty much the same way that you're doing it, except for OSPF, which changes from MD5 hash to IPsec. Otherwise, if you're doing MD5 hashes for your v4 BGP, you can do MD5 hashes for your v6 BGP. Control plane security. If you protect for v4, and I hope you are all protecting your VTY access on your v4, you can secure your VTY access on v6. This is something that if your security department is different than your network folks, and you say, I want to allow the /64 to have access, oh my God, that's too many addresses, you need to lock that down. We have had some security departments do that. It's like, well, you can't. Particularly if you're using Slack. That /64 is the network that's allowed access. I don't care if it's trillions upon trillions upon trillions of hosts, deal with it. And then you watch the security people's head explode and you walk away laughing. That's just something that security folks have to get their mind around.
The second group on a campus that should have v6 deployed to it after the engineers is security.
Yes.
Or is helpless?
Again, this is a small subset of my normal presentation, and that is basically get them involved early, so they're not antagonistic. It's because they're, you know, but again, security people are yes, it is very much a wrapping their head around it. And I know there's a lot of people here from a lot of different sized institutions, and in some of my institutions, the routing people and security people are the same people, which sometimes is very good. And then there are other places where there's a 12-person routing team and an 8-person security team, and they're always doing this with one another, and that's a harder discussion to have. But know that, again, if you have a /24 that's currently your network management access to everything network, it will most likely be a /64 in IPv6. You'll have to allow that access. No real change from v4 other than the size of the subnet. Again, there's the Juniper. SNMP, again, if you're doing any kind of SNMP gets from your routers, from your management, you're doing it for v4, do it in v6, again, /64. Again, this is very analogous to v4. There's no real changes other than the addressing. IPsec, again, all implementations of IPv6 must support IPsec. It's built into the protocol with extension headers. Standards-based, it uses authentication and encryption. You can do authentication without encryption if you so desire. That's what a lot of my campuses are doing with their OSPF, is they're authenticating, they're not necessarily encrypting. Because do you really need to encrypt your OSPF data between routers? If you want to, go ahead. You can use IKE for key exchange, but it's not required. And again, I apologize for not checking all my slides with the new theme. It's a relatively new theme inside our organization. But site-to-site tunnel, again, you create an IKE policy with a pre-shared key, IPsec transform, and then configure the virtual tunnel interface. And again, you can't really see it, but down on the bottom, tunnel mode, IPsec, IPv6. So it's not too terribly different from what you would do with v4. One other thing is on virtual interfaces, you do have to do IPv6 enable, which you do not have to do on physical interfaces. I don't think that's changed. It's been a while since I've tested this. It will yell at you if you don't need it. And again, there's the Juniper variant of that. IPsec for OSPF. Again, most of the routing protocols with IPv6 still use MD5 hashes. But you can secure your IPv6 OSPF authentication and or encryption. Same thing with the Junos. So you can set that up and have your OSPF as secured as you do with v4. Edge devices or edge security, access list, firewall filters, reverse path. And I'm not entirely sure what happened with the slides here. With IPv4, as everyone is aware, there's a deny any at the end. With IPv6, there are now a number of implicit terms. There are 2 extras to make sure that no one accidentally breaks neighbor discovery, because if you break neighbor discovery, you break everything. So just be aware that there are now 3 lines at the end of every Cisco access list to allow for permit neighbor discovery and then deny any. For audio purposes, that was RFC 6434, and that was changed from must to should for IPsec. For embedded type devices that are, stripped down stacks, I would imagine most of the laptops, desktops, phones, et cetera, are still probably robust implementations. So there is a whole other, yes, there is a whole other long discussion about embedded devices in IPv6 versus IPv4 that is totally outside the scope of this, and that they probably won't be supporting v6. That's the long and short of it. But okay, so I will change that for future discussions. So again, configuring v6 access lists. Yes, they're just like regular v4 access lists. You got the sequence 10, permit the address. So for anti-spoofing, again, hopefully you have anti-spoofing filters for v4. Only allow your addresses out, do not allow your addresses in. Same thing with v6. Don't allow address space that you don't own out. Do not allow your address space from outside in. This is not new news. There's the Juniper version of that. Putting it on the interface in the Juniper. Reverse path forwarding, again, best practice still holds. Same, so that's going through with those anti-spoofing filters. Again, depending on what routing hardware you have, this might be done in software. Most routers, modern routers, will be perfectly fine. But if you're doing reverse path checks on closet switches, you will find that the majority of them, particularly the older ones, will do this in software, and there is a definite resource problem with that. That was one of the things that my campuses have run into often is those older switches, particularly closet switches. They don't do RPF checks on them anymore because the resources just weren't there. You can do bogon filtering. So your BGP feeds from the Welsh people that I never pronounced correctly. There was that V4 feed that you could get that most people have gotten rid of because it's not worthwhile anymore. So everything's been assigned. They do have a V6 feed. Has anyone? Dave's skipping ahead again. And again, my slides are a little bit off-center. So when you're talking with your firewall folks, and again, some of this is older depending on when your last refresh was. Is IPv6 on by default? Hopefully by now it is if you're buying new. Although there are some that are still lagging behind. Is it permissive by default? So is it a default permit or is it default deny? What kind of feature parity does it have with v4? And do you have a way to easily allow for ICMP packet to big messages, which is, I'm assuming is where you were going with that.
That's one small.
Yes. Host firewalls. Host firewalls, as we've been saying throughout, in most cases, hosts are further in advance of many of the other devices that are out there. So Linux, you have IP6 tables, which is the one most people use. That's been around for a while. Works perfectly fine. Mac OS X and beyond. IP6 firewall. I'm not a Mac user, so all of the Mac users that are in here can confirm or deny that it works perfectly fine. From everything I've heard, it works perfectly fine. Windows, the built-in firewall supports IPv6. Older versions of XP did not do a very good job of that, but anything since then has done a perfectly fine job with supporting IPv6. There are some others that I haven't looked at in a very long time because what I found, in particularly talking with campuses, is they just use the built-in because they're much better than they were way back when. But there are some others that do a varying degree of good support for IPv6. Again, in a world where most of your devices are BYOD, adding third-party apps on top of it is difficult at best. So again, built-in works perfectly fine. In most cases, I don't see a reason why, particularly for your BYOD, you would want to add a third party. If you have a subnet that's controlled by central IT that wants to do some extra support, there are third-party applications that will do that. Again, depending on what you've chosen, it may do a good or a poor job. Network firewalls, you got the Cisco, you've got your Juniper-based products, you've got SonicWall, and you've got Checkpoint. Those are the ones that's primarily in my network people have looked at. We actually don't have that big of a install base of that I've talked with people about. So I have no operational knowledge of it. And if I can't... so on this slide, again, I won't go through all of this. I like to put a lot of versions on here. And this is all of the information. It's just shifted. So it started with version 8 with some features. And as you can see going forward to the more modern versions, features are added. You're starting to get feature parity. You're starting to get the ability to do policy-based routing, IPsec for AnyConnect VPNs, all of the other features that you might be using for v4. You're starting to see them get feature parity. So I like to leave that history in here just so you can see how it's developed over the years. And ASA version 8, again, we don't run firewalls, so ASA version 8 was a number of years ago now. You're way out of... Right. But my point was, as Alan was saying, people just parroting information that they heard a decade ago. If the last time they looked at this was when ASA version 8 was out and there wasn't feature parity, I like to leave this in here so people can say, yes, you're right, 10 years ago there was horrible support, but now look at what's in here. So that's why I like to leave that historical information on there. The SRXs, again, moving to Junipers, I haven't changed the net screen to SRX. I do have a link in there for their feature. Again, good support, robust features, getting towards feature parity. They're a good portion of the way there. SonicWall, I hope no one is trying to run an IPv6 network with SonicWall. I know we're not supposed to bash vendors, but their support is absolutely horrible. There are a lot of things they don't support. And since this is trying to actually operate a production-grade IPv6 network, I am of the opinion that you cannot do that with SonicWalls. IDSs, again, this was something where if you last looked at this 5 or 6 years ago, the support was horrible. In the discussions I've had with a lot of people about IDS, most of what you're looking at with IDSs is layer 7 traffic. Web, mail, SSH, FTP, whatever your researchers are using. In that instance, you don't care about what the underlying IP technology is. So all of the IDS stuff that you're doing at the application layer does not change, which is good. There are a lot of things. Yes, as long as you implement the underlying code. There are certain things with IPv6, however, that needed to be added to be able to do to use the IDSs properly for a v6 network. And I will get to some of those in the next few slides. So again, there's Snort, there's Bro, there's Bluecoat, there's Cisco, there's all these people that have implementations. Again, I don't touch on all of them because there's so many of them out there. Snort, again, basic support was added many years ago. It was enabled by default a few years after that. And as you can see with the newer and newer releases, this was the big one. The ability to look for extension headers. Extension headers, and not just block them. This was something, again, extension headers don't exist in IPv4. They do in IPv6. If you want your IDS system to look for extension headers, and there are particular attack vectors that use chained extension headers, there's some other extension headers that you don't necessarily want to see. Again, outside the scope, we don't need to necessarily go there. But you want to be able to watch them with your systems. So until we got to 2.9.7 or version 3, there weren't the signatures for those extension headers. So this is something that, again, as you get more modern, those features now exist, and you can be confident in them. There's also neighbor discovery type signatures that you want in there, which the newer versions can support. Bro, same thing. Basic support was added in very early, and the last version that I looked at, I think this is still the version that is most current, allows you to do extension headers, ICMP v6 message types, quad A records. Again, getting towards feature parity, getting to the point where you can monitor a production-grade network with those systems. Suricata is something that I saw kind of being adopted, but I don't know how widespread it is. Again, feature parity is getting more and more there. With the Cisco, with the IPS, again, you can do some neighbor discovery, but there are still some things that are missing as of the last version that I looked at. Again, depending on what you're trying to do, that might be sufficient for your needs. Going back to what I said at the start of this, IPv6 traffic at layer 7 is not any different than v4. It's application layer traffic. You have to be able to look for things like extension headers, neighbor discovery, if you're using it at all, the flow label, things that don't exist in v4. These are the signatures that you need to be able to have. If you don't have those signatures, then you're not going to be able to track them with your IDS and put whatever policy you have in place because of that. So again, your mileage may vary depending on what you want to do. Make sure that either those signatures exist or that you have someone that can create those signatures with the rest of your team. Again, feature parity is getting to the point where a lot of those signatures exist and you don't have to worry about any development. Lastly, applications, and this is getting more towards operations than security, but they are definitely related. So authentication, you can use v6. We've been doing it for years. Many of you have as well, I'm sure. Logging is the big one. This is not necessarily a security topic, but it is definitely an operational with some security implications. The main concern is not necessarily logging, because that's there. It's the reporting. So all of you are doing some kind of network monitoring. You're getting reports via rancid or whatever you're getting, and they're going into a file system, and then you're parsing them somehow in order to get you alerts. If your network parsing is basically, give me this IP address that's doing this, if that script is saying an IP address is 32 bits long, you are not going to get any IPv6. And a lot of those scripts have been written many, many years ago that are very well documented by people that still work for your university, right? So you're going to have to go back into those scripts that are 15 years old by a person who left 10 years ago and is now 3 jobs away and no one knows where they are anymore, and try to figure out how to go in and parse those and be able to do 32 and 128-bit addresses. Or you build from scratch, yes. But there are a lot of those. There's not just one of those. I'm sure there are many, many of those that you're using, and some that you don't even realize that you're using until they break. So this is one of those big things of implementing a network can be a lot easier than operating a network. There's a lot of these scripts out there that are doing, your top talkers. You are looking for malicious activity. If you're doing it, billing. All of these different things that are taking your reports and your logs and doing something with them. Whether it's homegrown scripts, whether it's database, whatever you're doing with them, all of those have to be looked at in order for them to be able to be certified that they're reporting back v4 and v6. And unless you take what Alan's going to be talking about over the next couple of hours and run a v6 network, you're going to have to report on both, because your users will be using dual stack. And you have to be able to correlate between this user has this v4 address and this user has this v6 address all at the same time, or this user has these v6 addresses. So you have to be able to correlate all of that back depending on what you're doing with that record. So this is not an insignificant topic, and it has nothing to do with building an IPv6 network or getting IPv6 users. It's I need to operate this network effectively, and this is an important part of it. And you said it took you many years to do this, and you've been running v6 for a long time. It's not insignificant. This is not, and definitely, right. Definitely do not hold back on your implementation until this is solved, because you'll never actually be running the v6 network in production. This is not to say slow down until this is done, but no.
It took you 3 decades to build all this up for v4.
Right. This is something that you will have to roll out and modify, and it might be running fine for 6 months, and then you'll be like, oh, this report that only runs twice a year just ran. Know that this will come up periodically. Database support, big one a few years back was MySQL didn't support 128-bit fields. That was a big one for a couple of years, and everyone was moving to Postgres. MySQL then started supporting it, and people stopped migrating. Most of your databases will be able to support addressing fields that big. In v4, if you're tracking this user has this IP address, in most instances, that user will have that IP address. And that's the only IP address that user will have, especially with DHCP and trying to get the same address. Depending on what addressing method you're using with v6, you will have to, and your data and your retention policy. So if your retention policy is 90 days, and you're using Slack and privacy addresses, you will possibly have up to 100 records, give or take, depending on how often that person moves and what subnet they're on. You could have many more for one user for that 90 days. There's a storage implication for that.
That's a well-behaved.
Yes, if they're moving from wired to wireless to this subnet to that subnet. Yeah, so if you have long data retention policies and IPv6 with Slack, you have a serious storage issue that you have to worry about.
Well, and even if you can solve the storage issue,
You have a parsing issue too.
where we ran into was indexing algorithms
Yes.
for data sets of that size.
Yes. So there's a solution to that, is don't keep records for 90 days.
Or act faster than 90 days.
Yes.
Not 2 years later.
You know, you definitely have to look at your policy in terms of, you know, if we keep records for 90 days, these are the issues we're going to have to deal with. So maybe we drop that down to 30 days. We have campuses that are doing 7 or 14 days.
Yeah.
It's your, you know, whatever your policy is. You know, we have many that have it be a month. It depends on what the campus policy is. This is more of a policy decision that has technical implementations with the now technical feeding back into the policy.
When I used to run on campus, the interesting thing is we would save memory at the router because we made the routing table so small, where V4 was just ginormous. But we've shifted that consumption of memory now down to the edge device or your databases.
Yes.
That went somewhere else.
Yes. So, again, there are things that you have to think about here. We're not necessarily going to solve that today. The nice thing about short retention policy is when you get a takedown request, you can say things like, there's no record of that anymore. If you don't have the record of it anymore, you can't tell them anything. But know that this is, again, something that should not stop you from doing a widespread implementation of V6, but something that you should be aware of and will have to solve. Again, with the logging, Rancid just works. Nagios works. Syslog, you can't do the stock syslog-d. You have to do rsyslog or syslog-ng. We made the change a number of years ago. I think we made the ng. Yes. Yeah. Yeah. So there are other reasons to do that, but it is.
I don't know if there's any like Linux distro that where stock syslog, as you say, is really a stock syslog.
Yeah. Yeah, we made the change a number of years ago. Again, I have to assume that there are people out there with very old implementations of stuff. Even of Linux. I just don't assume that people are running modern.
Probably still stuff out there that has IPv4.
That's ancient stuff right there. So application logs, again, same issue. If for some reason you are reporting back or the systems group is reporting back, here are the people that are hitting our web page. Here are the people that are accessing this resource, and you're reporting back based on IP address. Those reports will have to now include V4 and V6. The point was, even if your web server is V4 only, you're still going to get some V6 hits on it. So you're going to want to make sure that all of your application reporting is doing V4 and V6 and whatever correlations and whatever you're doing with those reports that are going back to whoever is using them. Those. Proxy 4, okay. Same thing with your DHCP server, your DHCP V4 and V6. You want to make sure whatever reporting you're doing out of that can do both types of records. DNS, same thing. Make sure your analyzers can report back on V6. Make sure that you're covering all of your users. Not really a modern problem. It's a bad coding problem. And some of it goes back to the literals that we'll be talking about later. But there are some applications out there, some software that will do embedded V4 addresses inside the V6, so they might be of a different format. There's some poorly written code that will do some weird things with the V6 address. So there's also some, again, this is not necessarily a modern code issue, but because there are multiple ways to represent an IPv6 address, everything should be reporting fully reduced, but there are some that might be reporting full 128 bits. Again, if there's clients, there will probably be 128 bits anyway. Know that there might be some times where the representation is different. Tools, Wireshark, and I have some demos if we have time that I could run through. Wireshark just works. You have to change some, instead of IP address, you have to do IPv6 address. You all probably have Wireshark. You could look at the wireless now and see all sorts of V6 traffic, particularly since we're on the IPv6 solutions for right now. I was looking at it before I started, and I saw all sorts of traffic from lots of people on it. Nmap. Originally, when V6 came out, this is now a number of years ago, Nmap did not work well with V6. because with v4, if you're used to doing Nmap on a v4-only network, say, please scan this /24 and report back of what users are there and what operating system and all the stuff that you used with Nmap. And for an IPv6 network, that's a /64. To scan that would be 28 years. You might have a few hosts drop. Yes. Yeah, it would be longer than the period of time that it would be useful, is the point behind it. So version 6 that came out, again, more than 5 years ago, changed the way that you do things with v6 in that it listens for particularly neighbor discovery to be able to generate the hosts that are on the network, because the neighbor discovery is periodic and you get a lot of traffic on that. When you're running Nmap, it listens for a while and says, okay, these are the hosts that are participating in neighbor discovery events. These are now who I'm going to scan. So it doesn't scan the empty space, it only scans who's actually active on the network. And that allowed you to do what you normally do with Nmap, is just report. It takes a while for it to report back. Nmap version 7, again, will allow you to do IPv6 specific scans, IPv6 OS fingerprinting, so more of the stuff that you're used to doing with v4. But it is available as a tool. There's also a number of other tools out there that would be new, as opposed to tools that you're used to using for v4. So there's the CPNI toolkit from Sci6. So it allows you to look for exploits that are v6 only, so your ICMP v6, your neighbor discovery, things of that nature. There are v6-based honeypots that are out there. That's just one of them. THC that's been out for years. I like IPv6mon, even though I don't have it on here because this is a Windows machine. We'll probe for IPv6 addresses that are in use. It's also a very good tool for doing correlation back to your MAC addresses for your user tracking. Slightly different discussion is using the use of /64 for backbone point-to-point links. Keeping the most recent argument on the IETF list about whether /64 is a valid subnet size, the convention historically has always been every subnet is /64. Yes, is the only size. That's the discussion we're not getting into here. So if every subnet is /64, there is a security implementation for that particular size of subnet on a link that will only ever be point-to-point. If you are never going to have anything other than host A or host B or router A or router B, why would you want to have a /64 subnet? And the security implementation is there can be a neighbor cache resource issue with that, and that there's an attack vector where you could fill up the neighbor cache to the point where that point-to-point link is brought down. Again, oversimplifying that, but for the purposes of this discussion. So the convention, I don't have the RFC number on here anymore, but it's fairly old. 6164, that sounds about right. The new convention was to reserve a /64 in case we change our mind later on, but only configure a /127. That way you don't have the neighbor cache resource issue. This is the only time, as of right now, where a subnet size other than /64 is a valid reason to break the convention of /64. If you want to have a rehash of that month-long argument on the IETF list, you can come find Dave and I later.
Or you can just watch it. It'll come up again.
In about 3 months.
Hey, Mr. Harrington, what's your opinion on those links to use link locals, or would you like to use some other type of IPv6 address?
My personal preference, I prefer global for a couple of reasons. The primary reason is I like to know this is what the address will always be, and if I set it, this is the address that it will always be. There is the potential, particularly on router-to-router links, because the link local address has, under the hood, in some implementations, a basis on the hardware address, which it really shouldn't, but some of them do. If you replace a pluggable, that link local address could potentially change. Not saying it will, but it could.
Not usually you're replacing the plugable, you're replacing the interface.
Yes, but yeah, if it can change.
So-
There are things that might change. I don't like leaving particularly my backbone links or my core links to chance.
But part of that is dependent on your religion of do you put those links in DNS or not?
Yes.
Do you want them publicly addressed so they show up in traceroute or not? Those are all heavily religious discussions.
Yes. So again, for the audio, that there is a component of that that has to do with, do you put your router links or your core links in DNS and make them available for traceroute, which goes back to ICMP and all that. There are issues that go beyond IPv6, that are IP based, that whatever you're doing for v4 you can do for v6. But my personal preference is to use global because I trust it more than link local because I have control of it. So Alan?
So there was a mention, and somebody may remember who did it. In fact, it may have been you on the working group call a couple months ago about how somebody from Cisco had said vanity link locals were becoming a thing.
Well, I think I'm the one that brought that up because when I used to be running the LSU network, we used predictable link locals that we hard set
Yes.
to make it work.
If you were,
And then that became
if
an
you are
RFC
doing,
somewhere.
again, the vanity or the hard set link local, that to me is not that different from setting global outside of the link local versus global portion of it, because you have control, you have hard set it.
Correct.
So I have less of an issue with that, just simply because I don't want something that's interfacing my backbone links that has any potential chance to change at any point and take down my network without me knowing why.
And it also speaks to the vanity or this hard set link locals. Speaks to the problem where you go to the v6 routing and you show IP route and it shows you a next hop is FE80 blah blah blah, right?
Yes.
And then you're sitting there going, well, what does that mean? But if you set them yourself, then you can see your special string in there and you know what. And it may clear up some of that.
Yes.
Yeah.
So if you don't want to use, to put this in a nice succinct, if you're not going to use global addressing for your backbone links or your core links, and you want to use link local, use vanity or hard set link local. Don't leave it to chance.
But the routers will give you link locals in a listing even if you have global addresses on the interface.
True.
Yeah, so that's my point. Yeah.
I was just going to make the point, operationally, using global addresses, at least that way you know exactly which interface has which addressing. And I'm thinking particularly in cases of ECMP, multiple routed links between the same pair of routers. If you're troubleshooting, you can see exactly which interface is going out and that kind of thing.
Yeah. So we have decided on global everywhere. Again, if we're one of the older, more religious argument things of I don't want my routers visible in traceroute, I don't want them in DNS, and you want to use link local or not to muddle the issue anymore, but ULA space. I'll bring it up. I'm not afraid of it. If you wanted to do something like that, again, don't. Because link locals, if you leave them to their own devices, will automatically generate. Site local doesn't exist anymore. Don't leave it to something where it's an automatically generated address, and for a number of reasons could readdress itself on you. If you want your backbone running that way, then more power to you, but you're leaving it to chance in a 3 o'clock in the morning alert. So that was the longer answer than you were expecting to that particular.
I probably should have rephrased it from the security context, but it was perfectly fine.
So one of the other big issues for many of my campuses, particularly when they are starting to move to IPv6, is I need to track my users for various reasons, whether it is for takedown requests, whether it is for billing, whether it is for... Yeah, I know. I wanted to introduce it first. Or whether it is for whatever, public safety, whatever reason they have, I need to know what user has what IP address at any time. And when I do this and when we come out of the addressing discussion of, well, there's Slack, and if you have privacy addressing in place, you have multiple addresses per machine per day, and they change daily or, relatively close to daily. Yes. Or you have DHCP-v6 and you have the issue of DUIDs that don't necessarily correlate to hardware addresses. That starts getting people concerned of, well, I now can't track my hosts. And there are a couple different ways that you can actually track your hosts. How many people in here scrape their ARP tables? When you scrape your ARP tables, you can scrape your neighbor discovery entries. There are some resource issues there, but there's resource issues with scraping your ARP tables to begin with. And as you can see, you have your link layer address in, you have both your global and your link local that are in that neighbor table. Again, now you have to parse that somehow, but you have the data. Big S database, yes, for your thousands upon thousands of users. But that method exists. So it gives you that correlation between v6 address and your MAC address, which you can't necessarily get from another method, particularly if you're using Slack. If you're using Slack, if you're used to using DHCP for v4, it's very easy to get user MAC address, IP address, that set of information. If you're using Slack, you now have no stateful way of doing that, so this is one way of getting that information. Just like scraping your ARP table must be run periodically, and you will have to adjust your data storage. DHCP doesn't cover everything.
Yeah.
So, yes, so, and DHCP, depending on what DHCP server you have, may not give you all of the information that you need. And let me finish with this and we can come back to that discussion because yes, if you have static, if you have Slack, if you have DHCP, and by the way, if you're running a campus network, if you haven't run into this anyway, if you want to support all your BOIOD devices, you're running Slack on your wireless. There's no way around that. So you're going to have a mix. So you can't rely on DHCP v6 for your user information. So you're going to have to do something else. Again, if you're scraping your ARP tables, adding this into that script, parsing it is one thing, but getting the information is not that big of a lift. You can use SNMP scripts. So instead of the IPNet to media, you have IPsec net to media. Yeah, you can. I have one person doing this with a small implementation. You have the issue of standardized versus proprietary MIBs, and you have some other things in there. Not the cleanest method. It does exist. You can use, again, tools. There are some things like IPv6mon that I mentioned before that will use a mix of active and passive probes to listen to your network and gather all of the information and place it into address files. You can use Nmap. There's some documentation on Nmap as to how to discover hosts. You can run it as a service, have it, again, logging and reporting back. There are some other tools. Know that there is a way to track users, static, DHCP, and Slack. There's a way to do it in v6. It just might be a little bit more difficult than you're doing with v4, and you've got all those built up. David's shaking his head, no, it's not that much more difficult. Just a little bigger. You'll have more data to work with, and you just have to accommodate that. This wiki space hasn't been updated in a while. I'm assuming it was a graduate student that started and then left. But it's got some basic information there about a lot of different things that I don't talk about. These are getting somewhat old. I tore the 2009 ones out of this. These are at least within the last few years, but IETF, operational security considerations, there's some NIST guidelines. There's some guidelines out there. There's, again, there might be some changes to draft levels on these. This one? Okay. I can't keep track of all of the different ones.
Well, actually, you do know you can just leave that off.
It'll just go to the most recent one?
Yeah.
Okay. Again, there's a firewall one. Again, the version may be different. And then security implications of IPv6 on IPv4 networks, that RFC. That's one that you can take back if there's a hesitancy to deploy IPv6 everywhere onto a campus. Again, most of you said you at least have some implementation of IPv6. You can use that as, here's what will go on our IPv4 network using v6 that we don't have any, operational insight into. Recommendations, again, we talked about it before. Do your first top security now. So block your rogue DHCPv6 servers, block your rogue router advertisements, set your router advertisement preference to high. Do that now regardless of your level of v6 implementation. Audit all of your equipment. And again, this was specifically for people that were starting their implementation. If you already have some v6, this is not a big deal. But especially those closet level switches.
The only thing is, that's one you need to continually do.
Yes. Yeah, that's not a one-time audit. This is with the new features, what is in software, what is in hardware, what is in this, what do we have to put on our refresh cycle in order to get what we want? Yes.
And what do we have to remember to turn? Oh, new feature available, but we never turned it on.
Yes. That's one that gets missed an awful lot, is when we first implemented this, none of our closet switches were able to do DHCPv6 snooping. Well, we refreshed them 2 years ago. Did we ever turn it on? That's something, again, that is important. And again, regardless of your level of v6 implementation, whether you're just starting out, you have it on some places, or you have it on everywhere, look at your tool sets. Are you running, if you're running periodic Nmap queries, are you doing IPv6? Are you, how are you tracking your users? What are your, all of that operational stuff of your logging and reporting, making sure that those tools are up to snuff. And again, sort of outside of this, but make sure your help desk is aware, make sure your ResNet staff is aware, make sure your security people are keeping up on the latest releases of things and making sure that the feature parity is there of, we had this report for v4, now we can do it in v6, so let's. Making sure that you keep up on that. But there are definitely some tools that you already have for v4 that can be used for v6, and there are some new ones as well. Yes?
One is some acknowledgments. First of all, Internet 2 providing the place to be in San Francisco and to have such a talk, set of talks. And they've been really supportive, and up to and including doing an AT64 SSID on the conference network, which is that other IPv6 SSID. Also, Cisco Meraki. And this should not be construed as endorsement of our message, because none of these people have looked at or endorsed our message, but they have provided the means to bring the people here and have the event happen. So Cisco Meraki was really cool about having Jeff participate and letting him be on video and all of that stuff. And Richard, who hasn't been going to events lately, said, I want to do an IPv6 workshop. And they said, oh, sure, because UAF really supports IPv6, right? And because they're such a great university. NiserNet, of course, we brought Jeff here to talk to you about IPv6 security. And Makiki Web, Craig Miller is a colleague of mine from about 25 years ago at University of Hawaii, and he went to work for Bay Networks, and Bay Networks got bought by Nortel, and Nortel moved him to Winnipeg, I think, and et cetera, et cetera. So now he's retired and he's living in Victoria, British Columbia, but he's been on some of our calls, and he's actually doing at a college, a small college up in Victoria, he's doing lectures about NAT64 and IPv6 and stuff in the community there. And he's taken part, and he's a pretty good reference for a lot of this stuff. So visit his website, and of course the University of Hawaii has brought myself here, and also Matt, who carried some stuff, so we're happy that they played a part. And I realized that this was probably my one and only chance to put the IPv6 Task Force Hawaii blog on a slide, so I did that too. Sort of, and Craig and I both blog there and talk about stuff. So if you want more of the same, you can do it. But and specifically, us guys who are doing the thing, who worked on the presentations, also Susan Evett and Jeff Hagley, who set up the network with his other guys whose names I didn't put on the slide, but I've been talking to Jeff. And then Mari Madrell without. So the IPv6 only network. We'll get to it. There is a definition slide, so I'm not going to waste my slides by talking into the title slide. So Jeff and I each contributed slides to this, so he may stand up and start talking in the middle of the presentation. It turns out people are interested in this. I came to this last, I don't know, for a while I've been thinking about this, and last April I started asking around to find out if there are any trainers, including Jeff, who had done a NAT64 kind of a slide deck and wanted to deliver it at Tech Exchange. And the unanimous answer was no, but we've been interested in doing that. So they're all interested in doing it, but they hadn't reached the point of doing it yet. Several people have volunteered plans for campus deployments, either as a try and see or to understand it as a tool. ITF, LACNIC, APNIC, at least, there may have been others, have done it on their meeting networks, and actually, as of today, Internet 2. WIDE project in Japan has done camps where they get a bunch of people together in a hotel over a weekend and in a hotel ballroom and just do kind of a LAN party for NAT64, and they collect a bunch of data and write it up in an internet draft or an RFC or slides for a ITF working group. So those are all sources of kind of encouragement and information. So the definition of IPv6 only in this case is a network where the end user devices have only IPv6 addresses. More importantly, their local gateway routes only IPv6, no IPv4. We may find our way to introducing some fake IPv4 addresses later in the deck here, but the answer is the router upstream of these users does not route IPv4. Possibly also where most routers and infrastructure also have IPv6 addresses, because as v6 addresses become more scarce and more valuable, you may want to squeeze the most bang for buck, to coin a phrase, out of each one of them. And then on the IPv6 only network, IPv4 is offered to users as a service over IPv6. Okay, so the game we're playing is we can't sit in ITF mailing list and discuss this for 6 more months or 18 more months or whatever. The deal is, the boss says, we're doing a general purpose end user device Wi-Fi network for 500 devices to be working by next Friday at 5 p.m. And I suggest we get it working by Thursday, because doing anything on Friday at 5 p.m. is a bad idea because you're going to be there Saturday. We're talking about solutions that are available for us to deploy at in the space of the next week. Perhaps assuming vendor equipment donations, because there's not enough time to buy a router. Perhaps assuming open source Linux-based routers and stuff.
The world is ending. IPv6.
They must be breaking down a room. It's all right. Ignore it. It'll go away. One time I had a thing about like this. I forget what event it was, but there was a wedding reception next door. Forget about it. So positive user experience is key. Elegance is priority number 12,397. The morally right way to assign addresses or DNS servers is a distant conversation. We admit that breaking DNSSEC is something we'd rather not do but also that nobody would notice when we deploy next week. Interesting new internet drafts or even RFCs are irrelevant unless they already have production-ready supported implementations. I really mean to stop gazing at our navels and put a network together. So at Hawaii ITS, we've been dabbling in the art of NAT64 DNS64 since July 2017. Several of us have done our work through such a setup on various days, noting some issues, although not really that very many. But by and large, getting work done without serious problems. In August, we hosted an OIN workshop with about 40 people attending. We offered a DNS64 NAT64 SSID during that meeting, and many people went on in the morning to try it and then just stayed there all day. I've been using IPv6 only with IPv4 AAS as DNX64, NAT64, 464 XLate in my office for about 2 months. It is indistinguishable from our normal dual stack network. I have not found a gotcha yet when you go all the way.
Actually, we do. Gotcha. It works. Bill
Yeah.
proved it.
Gotcha. So this is some flows per second out of the OIN workshop. I just captured the graph, and it shows that it tended towards doing more IPv6. And what I'm showing here is the real global IPv6 address traffic and the real global IPv4 address traffic, which is a translation block from IPv4 off the NAT64. So it did tend to, seemingly it did tend to promote more v6 prevalence. This is, just for the sake of interest, this is 3 graphs of the same time period off of our wireless, or one zone of our wireless, which is the same, I think, I talked about this before. And so I'm revisiting this, but flows run about 30% v6, packets about 60%, and bits about 50%. So using the things you have at home, we had a Cisco ASR 1001 not in service, and it had NAT64 capable iOS sitting on there, and we just turned it on and configured it. We had to upgrade iOS XE on a Cisco 4500, which faces our office subnet to get RDNSS working. We built VMs on Proxmox, did NAT64, 464 CLAT, I call it, DNS64, DHCP6, and DHCP4, and put an IPv6 only SSD on the IT building Aruba Wi-Fi with the key 64:FF9B:/96. We could have done, you could have done, if you just had an ASR 1001 and you set up DNS64, NAT64, and you use the common, the well-known prefix, you could just use Google's DNS64, or you could use a dual NAT64 with the well-known prefix and use Google's DNS64. Or you can just use the live demos at Go6 Lab in Slovenia, but you're hitting some major RTT to get to those. But if you just want to play with it one evening, you know, it's probably worthwhile. Your slide.
Yeah, so as Alan mentioned earlier, the point of the exercises we're about to do and get that frame of reference, we got to get things done. We got to get it done quick. And we got to do it what we have today. We can't wait on IRCs. We can't have excuses. We just have to do it. And my experience has been kind of unique because I used to be in the trenches like you guys. I used to manage a big, large network. And now I'm on the other side with an equipment manufacturer. It's been interesting because a lot of us tend to do the same things. We're adverse to change. We can't make things run today because we're waiting on RFCs to be published or what have you. But yet we have enough to get started, and it's time to get started now. And there's certain advantages, as you will see, that things just simply work. Hey, it's 2017 now. Things are much easier to deploy now. When I first deployed in 2006, it was very hard. Everything was very broken. When I say everything, was every operating system, every network vendor we tried, everything was very broken. So take advantage that things are easier, that a lot of us have been through the trenches. Now, there's still a lot of work to be done, but with that frame of reference, be very open when you're about to do these exercises and ask us a lot of questions. So go ahead, Alan.
Okay, so.
And actually, let me continue on this part. The other thing, too, with doing a v6 only network, which goes back to the perspective I was talking about, is you achieve some level of operational simplicity. Guess what? You're only supporting one stack now, not two. And then from a security perspective, like Mr. Harrington told us, he had to do things twice, one for v4, one for v6. But by eliminating completely v4 in this case, you only have to worry about one protocol in the IP stack, which means you just reduce dramatically your attack surface to one thing, not two. So those are key advantages of considering a v6 only network to solve a problem. Sir, go ahead.
It limits also limits deployment of real IPv4 addresses so that they may be used efficiently. They can only become more costly as time moves forward. Of course, the more V6 we depend on, the less costly they will become. So it's an interesting interplay in economics. And what it has over like a CGN or simply a big NAT 4.4 setup is that you're always doing the whole point to the NAT 6.4 is to do IPv4 as a service on a V6 network. So your V6 network gets you your YouTube and your XKCD and your Google Sphere and your Facebook and all of that stuff. And the answer to, if something is having a NAT problem, the answer is to do it on V6. So you will grow in V6, and hopefully shrink in V4, and like that. So your commitment to IPv4 deployment gets shallower rather than deeper. Dual stack does not really reduce your reliance on IPv4 addresses, but using IPv6 only connected clients does reduce your reliance on IPv6.
Yeah. One key thing too, also on the dual stack, remember dual stack is a transition mechanism. It's
Right.
temporary, even though it's been temporary for the last 10 years. You can go to the next slide, which is
It's kind of a dress rehearsal too.
yeah,
Really.
The other thing too is if you guys have kept up with the North American Summit, and I'm guessing they're not the only IPv6 working group that has been going through this. The last few years, the focus has been dual stack, dual stack, dual stack. That's how we solve this problem. That's how we move ahead. Well, it's 2017. A lot of things have been figured out. We have enough to make a V6 only network. Well, guess what? The shift in mindset for this year was, how do we do V6 only? What are the actual implementations that we have that are working today? Well, we saw several, and there's actually a lot of these videos are public. You can go see them. Some of them are very entertaining, really good. But we saw T-Mobile going V6 only if you were an iOS 10.3, whether you realized it or not. Cisco, which is my employer, is one. We did an experiment. We did, okay, on this summer, we're going to say this building's going to be V6 only. What can we learn from there? Which was an interesting experience because we figured out what breaks, what doesn't, what we need to work on, and it's just going to keep growing from there. We saw what LinkedIn and Facebook have been doing, and the Googles of the world. They have massive, massive data centers. They realize that they can't do it with CGNs. They exhaust an RFC 1918 just like that in just one site, so it's not sustainable. V6 was the answer, V6 only networks. So again, that mind shift has changed from dual stack to V6 only. So now let's go evangelize, and you're our starting class to do that.
That's right. So,
yep. And then right before we get to the exercise, I think we harped on it earlier today, and we were talking about it during the break. What is supported from an addressing standpoint? I know we've been discussing it depends on the operating system. Do we do DHCP, which has been something that we're used to for tracking and DMCA violations, and from a legal standpoint, we like DHCP. Also, does your operating system support it? We already know Android does not support DHCP v6, but there's tons of those devices that are coming to your campus. You still have to support them, so we have to go with Slack. Now, an interesting thing that has happened over the years as we've implemented v6 networks while it was dual stack was operationally, Slack was great. However, how do we deliver v6, a DNS server? We didn't have an option. We used to rely on v4 to do DNS, or we did some implementation of v6 just to give you a DNS server. It got kind of clunky, so over the years we added RDNSSS, which pretty much gave RAs an option, like DHCP options, to ride on top to deliver a DNS server. So we've been learning and feeding the IETF with operational experience because we need more of that. Because we live in the real world.
yep.
And things do get messy. It looks great on paper, but until we put it into production, that's when we realize, oh, this is missing. Oh, this is really bad. We may need to readjust things.
There's also been quite a few trials where people went and did for a conference or a weekend or a week, did NAT 6.4, DNS 6.4, and then they went back to dual stack or whatever they went back to. But I think part of the what's needed nowadays is to to live with it and just be there. And I can do that in my office now. I can totally just be a V6 only network.
Yep. And just don't fight it. If you have one particular preference over another, just don't fight it. The catch-all is to support both.
Yeah.
Because especially you guys all live in campuses that have been BYOD before BYOD was a word or a marketing term for our CIOs. So we have to support everything. So this is the best way. You don't limit yourself, you don't shoot yourself in the foot, and you're very inclusive of all the operating systems that come into your campus. Yes, sir.
I'm just curious, do you know what the reluctance is with Android and
That could be.
Well, we're not going to talk about it all day. We're just not that interested in it. But it has to do with their insistence that it doesn't support certain use cases they want, like hotspot, built-in hotspot, et cetera. And I think it's the funny thing is here they want to support these use cases by making everyone else dance around use cases that we're actually encountering. Yeah.
I'll tell you which mailer group to sign up, and every 3 months you'll get about 1,000 or 350 emails.
So there's this term IPv4 as a service, which has been kicked around and kind of refers to in a futuristic sense. But I've come to realize that it's really what I'm dealing with here, because I have a V6 connectivity, and as I say, I can browse everything that really, feeds my soul, which is XKCD and Wikipedia and Google, and I don't need V4 for those things. But there's always going to be literals, or I'm going to have to go to my banking site, or I'm going to have to do something, and there's going to be it's more of a philosophical construct than a technical. So this is a bunch of stuff that I tried sitting at my desk, and so one day I'm typing in Apple to go to apple.com, and the browser pops up a suggestion for Applebee's, and I thought, yeah, fat chance. I clicked on it, up it comes. Applebee's comes up in IPv6 only. I can find no other restaurant franchise that does. So
Probably not on Akamai.
things are, in fact, good in the neighborhood. Right.
Now, if you're a big IEEE person, IEEE Explorer does work, but not IEEE.org. Mystery yet to be solved.
Okay, and XKCD, ACM, although, yeah. Yeah, acm.org, www comes up, but not just acm.org. And if I forgot your thing, I'm sorry.
No, you guys should actually test your websites from your institutions just to see.
Well,
you already tested it.
if you don't have V6, wait till we do the NAT64 side, and then you can.
Then you'll be able to get to it.
Then, well, yeah.
Hopefully.
If we're being optimistic. So, last thing to try before we leave experiment 1 is to ping 64:FF9B. That's wrong. Look at the typos. 1:64:FF9B, and then and then you can just type a dotted quad after it, like a V4 address. And so, even though since I turned it off, DNS64 is no longer synthesizing addresses for you, because you can still reach the NAT64 by V6. You can translate through it by hand. In fact, if you type in this whole URL with the brackets included, it would bring you. Oh, it's actually, there's a link on the V6 only site to go to this at the bottom. And then what this is, it has 64FF9B is the well-known prefix for NAT64, and then : and you type in the dotted quad afterwards, and it'll bring up the V4 only page through the translator, which there's that. Alternatives, just some alternatives that are out there in the world to provide IPv4 connectivity to clients who need a package of IPv4 as a service, and some of the things that are done out there, DNS64, NAT64. DS Lite is enjoying some deployment, I think mostly in Europe. MapT and MapE, which I don't know a lot about, it's a Cisco thing. Anything to say about that?
Map is just a form, if you People think of it as NAT. One's just doing encapsulation, one's doing translation.
Right.
If you look at their history, the way they came about in the IETF, it was just pretty much came down to a coin toss. Which one was going standard track, which one was going experimental.
There's a quote about the coin flip on the Wikipedia page.
Yeah, they're very, very, very similar. It's just a one-step difference in actually when you code it.
Right. So V4RD is residual deployment is another interesting scheme, which is less implemented now than NAT64 and DNS64. So DS Lite, as I said, I believe it's mostly in Europe, and it requires you to have either CPE or the end user put stuff on their box, which is not what we're looking for. The V4 address is, I said fake, but it might be the 100 prefix, which is, I forget what that's called. What is that called? Thank you, group. We're skipping it because you need a CPE or a thing on your box, which is not what we're doing. IPv4 as a service that we kind of prefer is NAT64, DNS64, 464 XLate because we possess all the building blocks. Provides access to V4 content over a native V6 network through translation. DNS64 causes V4 traffic to travel with mapped V6 addresses. 464 XLate causes V4 traffic to get mapped locally. NAT64 handles translation of mapped V6 to V4 and NAT to V4 internet. Did you write some of this? Does not require specific capabilities or configure at the end user host. Right. So why we chose it over other things, it's the most widely implemented, it's mature, relevant scheme. It doesn't require you to change end user devices, meaning it doesn't require you to put software on end user devices. It doesn't even require you to reconfigure end user devices. When you bring stuff to this network, your regular configuration for your laptop should come here and work. There may be some, I've seen it on smartphones, I don't think I've seen it on laptops recently, is where the device will keep saying waiting for address, even though it's connected and doing internet on V6. It may complain because some of the connectivity checks are still kind of V4 heavy. It has a record of success with T-Mobile and others. It collects globally routed IPv4 addresses in one place, so that if you put them all in the NAT, so the NAT space is on the outside of the NAT64.
Yep, and the other thing in the North American Summit, like I mentioned earlier, it was the recurring transition technology that was being used. How people got to that conclusion just varied by trial and error or research they've done and things like that. But it seems to be the one that has the least moving parts that you need to go change and touch, which is probably why it was chosen.
Right. And so also, although it holds state, it doesn't affect your network topology. We'll show you a diagram in a minute, but you put it out on your network, and your network can route to it. And if DNS64 tells the client to send to it, it'll go there and it'll get translated. So if you want to exclude it from the equation, you stop driving traffic to it with DNS64. It's not an inline thing. There's too many tutorial pages on the net which show it as a bump in the wire, and it's really not. The NAT64 translator just has to be reachable on your network, and the routing will take it there, and then things will get translated.
Yeah. What throws people off is that word NAT, because we're used to having NAT just sit in line and do NAT like we think about it today in terms of V4, but in this case, it's not. So I'm NAT, you're NAT in your head.
Okay, so DNS64 RFC 6147 comes as a feature in Bind, as well as in other software, Power DNS, OpenDNS, Microsoft Server DNS. Assumes the existence of a compatible IPv6 to IPv4 translator. It's described in RFC discretely from NAT64, but it's they're generally joined at the hip. When it gets to request to resolve a name that has no quad A response, it responds by synthesizing a quad A response, encapsulating the A record response's IPv4 address into an IPv6 prefix, usually a /96, because 128 minus 96 is 32, and that just leaves just enough numbers for the entire IPv4 address space, which is the internet plus 30% or whatever. Synthesis per RFC must be reversible, and the reason I'm pointing that out is the bottom line. Theoretically, there's a lot of talk about it breaking DNSSEC and how it lies to, the people are using this rhetoric that makes it sound horrible, but the truth is that the number of end resolvers that ask for validation is very small. Most of the validation is being requested by a recursive resolver. Yes. So here's DNS64 in practice. Inside to bind named.options file, or named.conf options section, which is split up under Ubuntu in its own file, but there is a stanza, DNS64 stanza. And in this case, it's specifying the well-known prefix, which is easier to type than the one I'm using on the Internet 2 conference network. And looking at that stanza, these are a few of the more common, probably more prevalent options. First of all, the clients, you can put this on your recursive resolver, and then you can specify in the client's brackets what clients should be answered with synthesized responses. So you could have your whole network as dual stack, but you have one little NAT64 network, or network that you want to drive to NAT64, a v6 only network. Yes. And not only that, you can go, there's a recursive only section, which is this server has authoritative zones, don't synthesize for those. And I figured out why that would be useful, and now it's kind of escaping me, but I could see how. And then there's the break DNSSEC, which I'm not doing. I'm not doing recursive only. I'm not doing break DNSSEC. But that tells it if the client requests DNS validation, you should ignore it and send the response anyway. So that's all going on with DNS64 and bind. Other notes, DNS64 can live on your main recursive server on a caching forwarded server near your IPv6 only network. You can specify which clients get DNS64, others just get DNS. The DNS64 can serve from both IPv6 and IPv4 addresses, which may sound strange, but there's a reason to do that. And you can put a DNS server on an IPv6 only network, but if it has no v4 connectivity, it needs to forward to a v4 connected server because many domains don't have v6 connected servers. So the point being, you can't put a fully fledged recursive resolver with v6 addresses only. It has to have a way to reach v4. And I found this out by trying it and then going, oh, I know why it's not working. So there's some forwarders and some forward-only statements there. So DNS64 and A records, resolver behavior, happiness-oriented browsers and legacy yet popular like Windows 7 OSs may still choose A records if it's presented with both. And DNS64 does not neglect to offer an A record back to you. If you ask it for an A record, it will tell you. If you ask it for a quad A record, it will synthesize if there's no v6 address. So it will still answer A's, and what I just said. If the goal is to promote v6 use, you want to drive more stuff to v6 off of that segment, off of that network, you could possibly, it may be desirable to deny the existence of the A record. So this A record suppression has come up in a couple slide decks and documents from the IETF user experiences on NAT64, but they were mostly talking about experience issues with happy eyeballs and stuff, not to maximize IPv4 use. Or what I mean is to make the most efficient use of IPv4 by pushing things to v6. And I'm not suppressing any A responses today, but So NAT 6.4, the next building block in the puzzle, is NAT that shrinks, hopefully, rather than NAT that grows. Better than NAT 44 for various reasons. One is it begins as an enhancement to a V6 network. The more IPv6 grows, the less NAT you have to do. Promoting native IPv6 reduces the use of NAT v4 address port space. It's better than dual stack because the more you shift to IPv6 only networking, the less you spend on precious IPv4 addressing on building an IPv4 network, like router interfaces and management and switch interfaces and et cetera. As IPv4 addresses become more expensive and more scarce, providing native IPv4 addresses on a per interface assignments becomes pretty much unthinkable. If you've got a few addresses, you can stick them up there as a NAT translation space, and you get 64,000 flows per address at a time, rather than using a whole address on one device. NAT 6.4, it accepts package destinations for translation prefix destinations and translates them to IPv4, and then it accepts response packets from IPv4 destinations and sends them back to the initiator. So this slide actually should say stateless or stateful NAT 6.4, because if you set up stateless NAT 6.4, it's the next slide. You can build this in front of this stateless because you build a table. You tell it what address goes with what address, or you map directly. You can actually give it a block, and it'll map from one to the other and back and forth. So if you have some resources that you want to be available on IPv6 and they're not, you can put this in front of them, and the IPv6 internet can get in there and access those v4 resources. And so it could be useful, but it's probably most often advisable just to turn on v6 on the thing. But of course, there's going to be those little wrinkles where you can't do that. And one of the things I noticed doing IPv6 audits on networks, where you go through the whole network and just look at everything and see what it would take to move to v6, is there's HVAC, there's microwave and power management. There are these things that live a lot longer than typical laptops and networked boxes and stuff. These are like 20-year lifetime devices. And a lot of them, it just doesn't make sense to swap them all out because they can't do v6 yet. It makes more sense to kind of put something in front of them so you can deal with them from v6, or to maintain a v4 network for management until they die. But there's a lot of really long life stuff out there that needs to be dealt with somehow. Stateful is the one we're going to talk most about today, and the one we're going to use. It uses addresses in the form of, you take the v4 address and the well-known prefix, and you tack the v4 address on the end of the well-known prefix, which, God bless whoever came up with the appended dotted quad notation, because that makes it a lot easier to type addresses. But it comes out looking like that after v6 reinterprets the number. So we have two active NAT 64s running at U Hawaii. One is the Cisco ASR, or iOS XE, which is kind of the Cisco flavor of iOS, where most of the exciting stuff is happening lately. I guess, anything to say about that? Okay.
You're spot on.
Okay. So they call it flavors, huh? The documentation is not really plentiful. I actually have a configuration, and I need to put it back out on the internet because I found several places where people were discussing this in some discussion board, and it's just a little odd to set up. Probably more scalable than a Linux router, but that's just a guess. ASR is a pretty decent box for stuff like this. Although if you take the same version of iOS XE that's running on our 4900s, for instance, NAT 6.4 is not there. So it depends on the platform, on the hardware underneath it. I'm also running a lot of little, wow, you just wonder what they're doing up there. Yes. It's the Hulk. Ubuntu 16.04 boxes on VMs with Joule NAT64, which Joule is at Joule.mx. It's a university in Mexico that's developing it. It's very active development. They've got plans for the future. Right now, they kidnap packets out of the NetFilter chain, and then they reintroduce them a couple hops later, which I found to be the best model that among the open source NAT64 stuff that's out there. And it works pretty well. They've just recently on the Joule mailing list have been doing Cisco T-Rex throughput tests, and it passed with flying colors. So it's doing pretty well. And their website is probably the best documentation of NAT64 that I've ever seen anywhere. You can go there and you can read it all and be much more edified. So just a couple slides about what it looks like to set up NAT64 on iOS XE, which is you got your v4 interface. That's not my real OSPF authentication key. You've got your v6 address. It's actually not the real addresses either. Those are the dock addresses. And then you've got I had kind of figured this out for myself. You have to redistribute static because, as I'll show you right here, if you do show IPv6 route stat, these two routes are in there after I configured 2001.odb8:f0. It instantiates 64FF9B just because it wanted to, and it put that in there as a static route, and then it put the one that I typed in as a static route. So I just noticed that they were in there. And then I did redistributed static, and everything started working. So then you can see there's a v4 pool there, and then there's a v6 v4 list NAT64 ACL, which I went back and opened up to allow the conference network to be on this NAT64. So it's the ASR that's doing the Internet 2 IPv6 only SSID for TechX. And you've got some statistics. These are kind of interesting. You can show all of the translations that are going on. When we had, I think, 28 people on during the OIN conference, it never got past the first v4 address in the pool. Everybody was served by that first v4 address. So, and then stateful NAT64 on Joule, Linux, Joule 3.54. It's pronounced Joule because it's a Mayan word, not a Spanish one. I actually asked that. I didn't want to go around saying Joule if it was Hool. Well, you tell me I'm stupid.
No, you're not. It's just
okay. I'm always afraid that I'm mispronouncing stuff horribly when I'm talking to people outside my immediate vicinity.
There's a big called Alan Weiner,
Right. Which I don't even hear. It's not that important to me, so I don't even hear it. Actually, somebody recently pronounced it correctly, and I said, "Wow." So I've been setting it up on Ubuntu 16, and I did Raspbian 8, which requires a kernel module compile, which is a little complicated, and I have instructions for it, which I need to publish because there's some workaround instructions on the Joule website, but I have the ones that actually use the way it's supposed to work. It is the only Linux-based SIT NAT64 solution I have tried, and it's currently very actively developed with attention on functionality and performance. And it seems to be the best of breed in terms of the.
So we can do both stateless and stateful?
Yes, it can do pretty much anything you can think of. Until 3.2, it was stateless only, but they've recently got into the stateless money, the stateless business, which is where the big money is.
Well, it's a data center solution.
Yeah, well, they got. You're right, SIT-DC. Yeah, they got that too. You can read about all that on Joule.mx. So you need to set up your Linux like a router/translator. You can do one-arm NAT64 pretty easily. That's what you do on Raspberry Pi because it doesn't have two interfaces. And the following assumes separate v6 and v4 interface. So first of all, in rc.local, because I'm a coward and a bad administrator, I put all this stuff. You have to turn off offloading on the NIC because segmentation offloading is bad if you're trying to translate packets, or they have explanations about. Yeah, stop helping me. Ow, ow, ow. So, but you do that for this machine has two interfaces. You do it for both interfaces. And then you do the mod probe to load the Joule module. And then there's a user space binary called Joule also is what you use to manage Joule. And I added a bunch of addresses to the pool. In syscontrol.conf, you put the forwarding for v4 and v6. And you can change the limitation on ephemeral port ranges that are chosen by Linux by doing something like what I did here. And what you find is if you're not running a web server, you're not running a mail server, you're not running any special stuff, you can choke it down pretty hard and give it like 1,000 ports, which is probably still pretty generous if you're not doing very much. And then it can use the rest of the range above 1125 to just do NAT64. Also, I was kind of hoping that the ASR, I didn't have to do something like this. You just tell it the pool, and then when it gets one of the pool addresses routed to it, it knows what to do with it. But on the Linux box, I had to make those addresses appear on the interface by doing extra like virtual, whatever you call it with the colon on there for every address, and then things were cool. Also, don't let it configure the broadcast, because it will happily use the broadcast, but the router don't want to forward back to the broadcast because routers are sticky like that. You can use there's some monitoring of the Joule command. There's also a Joule D, which I don't have a slide for. Joule D is for clustering. You can have multiple NAT64s, and they talk through Joule D through a multicast group on a wire, which is cool. Okay, NAT64 is a service on the network. I export the routes into OSPF, and then any IPv6 connected host can use it. Let me think. Yes, when I did, so you can do ACLs to limit what can be used. In fact, on the ASR, I have an ACL, which I had to widen out to let Internet 2 in. On this one, I don't think I'm doing any ACLs, but they probably do specify that in the instructions as something you should do. The ACL meaning limit it to the clients that you want to be able to do translation. Of course, you may want to keep it pretty wide open and just do your whole network. Or a /48 or a /40 or something, so that you are allowing your whole place, and then you can just tell people if you want to build a v6 only network, use this translator, and here it is. So neither NAT64, neither the Cisco nor the Joule can reach itself. So you go to the agent on the box and say ping 64FF9B, blah, 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 and it won't know what you're asking it to do. So you got to route the packet into it from outside, and then it translates. So then that makes you deploy more boxes. Actually, with Joule, you can put things in different Linux networking namespaces on the box, and you might be able to, we'll offer a loving cup or a box of donuts or something.
This probably has an aversion to hairpinning, which is.
Well, hairpinning is something, but it handles hairpinning, and that's possible with the latest Joule. But yeah, but if you want, the point being, if you want to stuff all this stuff on one box, you're probably going to have to get really agile with your Linux namespaces.
Or virtualize the box.
Right. Yeah. Build a hypervisor and put boxes on there. I actually show and tell time. Plan B. I have 3 of these with me, and I actually built a network with these and an Ubiquity AP in case there was some reason that Aruba wasn't going to work. But this is Jerry, and the other 2 are Summer and Beth. Do you know who that is? He does. That's Morty's family in Rick and Morty. So, but these little Zotacs are great because they have 2 gig-E's on the back. I have it as a router at my house. I have a little Debian router at home. But they're really cute and they're full-on 64-bit Intel architecture inside, so and fanless, so useful for some things, no doubt. And then abracadabra. This is you probably all read this slide and ignored what I was saying, but with NAT64 active and routing for the translation prefix set up, if you remember what the prefix is, you can sit on a v6 only host and reach a v4 only host just by typing the stuff in. And that is a problem you run up against when you're doing v6 only network. You're on the wrong command line and you want to reach the other side. Well, if there's a NAT64 anywhere on the network and you can route to it, you can just do this and SSH through the prefix, through the translator. Yeah, so it's a little, it's very dicey caching negative results and then trying them again.
These machines are trying to be too smart for us.
So note that there are still no IPv4 addresses at the clients. If you encounter failures, they're most likely caused by IPv4 literals, which are numeric IPv4 addresses embedded in HTML or software code. Since numeric addresses do not require an address lookup, they're not resynthesized by DNS64. So why do some devices get the apple? Because they have built-in 464X-late CLAT. When such a device joins a v4-only network, it queries the quad A record for v4only.arpa. And then, of course, since v4only.arpa has no quad A record answer, if it gets an quad A answer, it's going to deduce the prefix and be able to deduce the prefix and knows about DNS64 and NAT64, including the synth and translation prefix. So 464X-late is actually a superset of NAT64. It includes NAT64 in its sphere of influence, but it adds another piece to catch the either on the wire, bump in the wire, or on the host, bump in the stack, bump in the host, bump in the browser. And you do notice, and I've noticed, and we didn't really make a slide for it, that the browser is another layer here. Often the OS is doing one thing, and then the browser has its own DNS cache and its own life, and so you kind of have to recognize all of that stuff. And at this point, eyeballs are only moderately happy, but 464X-late employs 2 pieces: the CLAT at the client, I say CLAT, and the PLAT at the provider, which would usually be the NAT64. Takes the stray IPv4 packets, it translates them, it sends them to NAT64. It has 2 styles, which is probably incomplete, but what I'm pointing out is bump in the wire, meaning that there's a local device on the network which handles v4 packets that sneak out there. But that only occurs when you provide it with a v4 address to get on the wire with. And then there's bump in the host or bump in the stack or bump in the browser, and those things are going to use that v4only.arpa lookup to determine that, to figure out what's going on, and it's going to catch v4 literals before they get out to the interface. See, even though, even if we had something on the wire, which we actually do, to translate those, catch them, we're not providing any v for it. So yeah, people don't say 464 CLAT, but I do. I made it up. It involves, so we were talking about NAT64. Now we have an extra piece called a CLAT, and I coined the term 464 CLAT. Use it in good health, no need to thank me. Oh, I think Chrome. It's a Safari only thing.
No, it's working for Chrome.
For you? Well, just for you, but who knows what you're up to?
I don't know.
Okay.
I don't type it out.
Well, it's actually, we have the general network for the conference, which is on other meetings, probably. If we just decide that the conference network is good enough, maybe I won't, but So 464X8 with Joule SIT. Joule SIT is a different module from Joule, and you can set this stuff up. You got to set up the V6 and V4 forwarding. This is a separate host from the one I was setting up before. And then you go in rc.local or wherever you would like to do it, and you have to add a IP default route, IPv6 default route, because when you enable forwarding, it will promptly drop all router advertisement derived information and cut you off at the ankles often. But so use a direct console and keyboard when you're configuring this. Then that's the invocation for mod probe. You just give it the pool, which is the prefix. And then you give it another prefix. This is a prefix we have not heretofore used for anything. And what that is the bump in the wire gets the V4 packet, and it has to make it up into a V6 packet to ship it off to 64 FF9B. So it needs a source address. So there's another block, a 96 block, that starts on the bump in the wire box, and that is just, and that I actually considered doing like a ULA for this, because it just goes like around the corner and never goes anywhere else. So you could be a little bit creative with the kind of address you use there, or you can just use a global address and sleep easy at night, knowing you've done the aesthetically pleasing thing. So, and then you set up a DHCP v4 server, which is nothing special about that, except that to begin with, you never tell it a DNS server address. You don't want it to supply another DNS server address. But I'll say more about that in a minute. So, experiment 3, which I will turn on. Let's see if I can do it quickly. Oh, no, it's the same box. No, it isn't. Okay. This box is on the wire with us. What's that?
iMessages works just fine.
Oh, good. That's great. So the DHCP4 is now running on the bump in the wire, so you may want to unjoin and rejoin or something to restart the network configuration. I mean, in time, it would probably find it, but we don't want to wait that long. Well, actually, go ahead and talk.
So we were talking about SIT and some other things. You can really only have one sort of translator and one translator technology using the well-known address at a time.
Yes. If they're in the same routing space.
Yes.
Yes.
There is just recently a new RFC that is in 8215, and that defines a whole new prefix, a /48 of address space that can be used for local translation.
Okay.
And the prefix is 64:FF9B:1::/
Right.
/48.
Right. Yeah, it's notable that 64FF9B is only 40 is only.
96.
It's only a /32. What's the number part, right? It's actually 64 : FF9B : bunch of zeros and then /96. So there's a bunch of zeros in there that you can work with.
Well, no, you can't, because those the bunch of zero ones are undefined.
No, I know, but like you just said, you can like write another RFC or make another allocation. I don't mean you can never ever do that. So, but I meant what you're talking about.
Yes.
Go forward and have like a /48 or whatever.
So there's been a /48 defined. Now, one of the things, one of the cautions that is talked about in the RFC is there's issues about for translation, you want to pick your addressing carefully so that you don't have to manipulate your you don't have to manipulate what's the word?
You're talking about external routing, or?
No, checksum. You want to pick your addressing your translator addressing so there's checksum neutrality, so that you don't, so that changing you don't change the checksum of the header and some things like that.
Okay.
It makes your translation quicker.
Right, and less larger and smaller carbon footprint.
Yes. So, which that was taken into account when 64 FF B9 :0:/69 was selected. By giving you this bigger prefix, you have to sort of do that for yourself.
Right. Okay.
And it's talked about in the RC.
Well, we'll look that up. So using the dual SIP module, we've now put a NAT46 on the V6 only wire. The NAT46 offers RFC 1918 addresses and DHCP4 to the host on the wire and poses a local V4 gateway. Clients send packets to the specified CLAT, which then takes the packets and translates them to V6 and sends them to PLAT, which is our old NAT64. This is the full diagram. And this raises an interesting question. So now I'm providing a DHCP server on the wire, and I'm offering DHCP to clients. Do I need that nasty old RA-based RDNSS anymore? No, because I can offer the DNS64 as an IPv4 address to the clients now. And this actually works. So if you put the DNS64 IPv4 interface in the space in the RFC 1918 space, then you wouldn't chop up any translation addresses when you were using it. But you don't have to do that. You could just route, and it turns out that my first DNS64 that I set up, I actually put a v4 address on it because it's less typing. And I got it going, and so I just tried this. And so you reach the point where you can support Android without doing RAs and Slack. So I point that out. I think that I was going to say less elegant, but what do I care about elegance? It might use up your translation space a little more. And DNS is a very busy little protocol. I mean, it takes up a lot. It accounts for a lot of the flows that go in and out of our domains, in and out of our networks. But it's just a point. And finding routers that do RDNSS is a little harder than finding routers that do DHCP v6 forwarding. Like all of my 6500 routers on the UH campus will do DHCP v6 forwarding, probably because it's an older concept. So right now, you've got, if you have an IPv4 only address or a device, it will work on this network. If you got v4 literals and v4 only content and v4, URL rewrites and Skype and and whatever else it will work on this network. I've not found any significant glitches in just using this all the time. There seems to be more of that happening than is generally acknowledged, although it's not a well-documented thing on the internet at large. Okay. So I had an ASR. I used an ASR. I didn't go out and canvass vendors for boxes to try different things. We also probably have a retired Palo Alto appliance which could have done NAT 6.4, but I didn't get around to that. So Cisco, iOS XE, there's also an ASA flavor under Cisco, obviously, because the firewall-y stuff tends to do well in this space. In fact, maybe it's a little more prevalent than routery stuff. Juniper does the MXs and SRXs, perhaps other stuff. So Microsoft Forefront Unified Access Gateway, which is like a generation ago. But Microsoft, as always, but not in their subsidiaries like Skype, is pretty well forward. Palo Alto, as I said, A10 is big in the space. And both the ASA and the Microsoft and the A10 include both functions. You do DNS 64 and NAT 6.4. You're not supposed to say 64, by the way, but I don't care. And then F5, one of our Internet 2 member campuses, is looking at doing this because they have engineering interests on campus that want to mess around with V6 only networks, and they have an F5 appliance in front of them, which does. Yeah. So there's probably other things, but I haven't rooted them all out. But wait, there's more. So Aaron constituents, which is almost everybody, sorry, David, in the room who intend to employ IPv6 transition technologies can pretty easily receive an IPv4 block in size between a /28 and a /24 to use for that purpose. Because when Aaron got the last /8 from IANA, they actually just set aside a /10, and then in the new number resource policy manual, they coincidentally numbered section 4.10. It's IPv4 /10, which you can go look at. Aaron's ready, willing, and able to do that, and they've even implied that it isn't that hard if you're doing NAT 6.4 or if you're doing a V6.
There are some other terms. One is that you have to be able to show you don't have any other v4 addresses available to you that could be used for this purpose.
Right.
This is sort of a last resort.
Yes.
But there's a last resort.
Yes. But if you're in the position of the college that I know of that has the /28 to their name,
Correct.
this is a windfall of epic
Yes.
proportions.
And in fact, it'll be a /24 because
Yes.
/28s aren't really routable on the internet right now.
Yeah, I didn't want to say that since I don't have documentation, but thanks for saying that.
Well, being one of the people that helped write this thing, I kind of know
I'm
it.
pretty sure that I've heard it alluded to by Aaron people.
Yes.
But I didn't have a reference.
But
so.
this is one of the few blocks of address space that Aaron has and actually can give out without you sitting on a waiting list for a purgatory.
Yeah, so I have also heard that APNIC and RIPE both looked at it and voted it down.
Yeah.
So, and I don't know about the other.
Well, they have a more general purpose /8 policy.
Yes.
That basically, if you become a member, you get a /20. You get your last dole of address space.
Okay. All right, so in NAT 64, if you had 256 addresses, or 254, it would support on the order of 16 million NAT mappings. So this is Jeffrey's slide, so I'll let
Yeah, and then last but not least, again, like we showed earlier with the video, you can do cool things like segment routing. Also, what's coming down the pipe in the IETF is this concept of PVDs, provisioning domains, which is kind of it's not really a new concept. If you think about options, which I've mentioned earlier, DHCP options, how we can configure stuff by just throwing more information at it and then letting the client figure out what to do with it, that's kind of the premise of PVDs. Because one interesting problem that we know with IPv6 is that single interface that you have on your laptop can get multiple addresses. What happens if we got an address from 3 different networks? How does it know which one to use, which one to route, which one is actually working? Well, hopefully PBDs will be able to help let the client make that decision and know which way to go out. Or maybe I use all 3 because these are all 3 different internet drains that we have on our campus. So it's providing more intelligence to the end host to make you be able to do interesting things. The other interesting thing is captive portal. The captive portal group, you know how painful captive portals are when we go check into the hotel. If your VPN's on, it won't detect it. Or depending on the operating system, they do different checks to see if they're behind a captive portal, and that's what forces it. But if you go to an HTTPS website, nothing happens. You're just dead in the water waiting, and you got to go to a website like CNN or that doesn't do encryption or stuff like that. Well, they're going to start looking at PVDs, and all major operating systems actually are on board as of this summer, saying, okay, we're going to look at PVDs to be able to resolve that problem of captive portals. And PVDs can probably do more than just that. So just something to keep an eye on. So it's, again, and it's all riding on the premise of it has to be V6. Will they build it on V4? Highly doubtful.
Sunset, man.
Yes, sunsetting of IPv4. So I guess we can end. Here's an, go ahead. Here's another project that is doing, if you like to play around with Linux boxes like Alan does, it's open source. It's called VPP, and we're probably going to see that come into Cisco routers and other platforms because it's open source. And then to end today, we really appreciate you guys being here. 2 main takeaways. There is some still IPv4 space available to you if you belong to Aaron. We heard the stipulations from Mr. Dave Farmer. And then second, do you guys agree that IPv6 can be a problem solver in your campuses today? Honestly.
Okay.
And then icing on the cake, we saw things that are coming that will be able to do cool things on your campuses because you're running V6.